Welcome to day 2 of Microsoft Build. How is everyone?
Let's get the energy up.
That was pretty good for first thing in the morning on day 2. I'm not going to do the thing where I'm like, oh, I'll do better. Anyway, I'm Burke. This is my colleague, Pierce. We were just talking about, like, what is your title? What do you do here? What is it that you say that you do here?
So I work on the VS Code team, but I also work on all things GitHub Copilot, GitHub Copilot app, CLI, et cetera, et cetera. So things.
Things. And my name is Burke. I also work on Copilot CLI, Visual Studio Code.
Yep.
I do my best to make some YouTube videos from time to time. And otherwise, just sort of hang out with Pierce.
Yeah,
a couple of announcements for you today. So this right here is streaming Windows stuff after 2:15. So if you want to hear Windows stuff, this is where you definitely want to be. Hi to everyone watching here at Builds. I guess that's y'all. There's nobody. Yeah, that's just these people here. Okay. And then also the people watching online on our social handles, VS Code social handles, on YouTube, on X. I guess we're streaming on X as well.
Yep.
GitHub, YouTube, Microsoft Developer. Terminal Live, the live coding from the expo floor. Have y'all seen the live coding booth? It's like a glass, it's like a fish tank with people inside. Can anyone go in there, or do you have to be?
I think you have to be sanctioned.
Do you have
I'm going to be locked in there for 2 hours today.
Are you really?
Yeah.
What are you going to build?
No idea.
Huh, interesting.
We'll find out together.
Anthony was in it last year. Didn't you build like a programming language or something? Yeah, Anthony built a programming language in 10 minutes because that's what you can do now. I'm sure it works too. Everybody's using it. Let's see. We have from 10:15 to 11, VS Code team's AI adoption story. That's breakout 204.
Yep.
Is that yours?
That's my, yeah.
That's you and?
Me and Josh from the VS Code team. So
okay.
The basic concept is like, okay, you use AI, now what? There's a lot of things that break.
I thought it was going to be about like our AI adoption story, like why we put AI in Visual.
No. It's like literally like our team uses AI now. Okay, now what?
Gotcha.
Yep.
Interesting. Okay, and then we have the Copilot game show that's going to be happening on the keynote stage.
Yep.
That's going to be a ton of fun. 𝗦𝗲𝘀𝗀𝗃𝗀𝗃 is going to. Do you have to say the C when you say 𝗦𝗲𝗀𝗃?
I don't know.
Where's Kent?
Where's Kent?
Yeah. Anyway, he'll be there co-hosting. We're going to try to We're going to vibe code something in 45 minutes. See how far we can get. It's going to be a lot of fun. Join us for that. And then we have monthly release live streams, y'all, on the VS Code channel. If you want to keep, because look, how many people have no ability to keep up with what's going on right now? Am I the only one? I work on the product and I don't know what's in it because they're shipping every 15 minutes. Those monthly release live streams are a really good way to keep up with everything that's going on. You still won't know, but at least you'll know more than you do now, right?
Yep.
It's not possible to keep up with everything. And then they want me to mention the blog. I'm not doing that. Okay, opener. We just said all that. All right, Pierce, let's talk about the highlights from day 1.
Let's do it.
So first, let's talk about the GitHub Copilot app.
Yep.
It's this new thing. It's an app. It's not an editor. It's not a CLI.
Yep.
What is it exactly?
It's an agent-native desktop experience for building things. So like, that is a very marketing answer, right? But I think we've all kind of used these session managers, right? Where you spin up some agents, you're running multiple things at once, they're isolated in Git work trees. And so like the app can do that too, but really like when you think about your job, right? There's a lot of work that is around all that, right? Like deciding what issues to pick up, triaging your backlog. Once you actually do stuff with agents, okay, sure, you submit a PR, you have to get it across the finish line. The app helps with all that stuff as well.
So I've noticed this. I don't know. I'd just like to poll the audience, but how many of y'all are actually running multiple agents at one time? Okay, so several folks. Like more than 2? More than 3? Anybody out here running like 50 agents and your screen is just a bunch of terminal sessions, or is that only on social media? Like no one is doing that. So I did have this question about like how many agents is feasible, in your opinion, inside of these apps to run? Like should we be running 50 agents at one time? What is expected of me now? What am I supposed to be able to do as a developer? I don't even know anymore.
I think there's a lot of performative productivity of like, to your point, people running 50 things at once, but it's just like always, like when I sit down and write my performance review, it's like, what impact did I deliver, right? And if I can get there by running a couple things at once, great. I personally don't think I can go beyond 3 or 4 because I really start like losing track of what's actually going on. And I have to batch the tasks together. I can't like constantly just be jumping in and out of things all day. So for me, I think the max is 3 or 4, but with the app, like even if you're only running one thing at a time, the interesting thing is like the code is intentionally backgrounded, right? We have an awesome editor, VS Code. If you want to see the code, you go to that. But the whole point of the app is you can stay outcome focused. So there's like a browser, you can click one-click run, and so your first like kind of outcome that you do after the agent is finished is you're actually checking to make sure, did it do the thing, right? And then secondarily, you know, how do I feel about this code? And so the app is more focused on that first problem than the second.
Do you really ask yourself how you feel about the code, or?
Depends.
You're
it
supposed
depends what
to
I'm
ask
working
yourself
on.
that question, but then you're just like, it works. I'm just not gonna look. Because here's what I've noticed, y'all. With these new tools, it's like out of sight, out of mind. You know what I mean? Like if you don't see the code, then you don't get nerd sniped into worrying about it, and it just goes, and you're like, does it work? I don't know. This has been my experience. So the other thing we had is, we got a lot of stuff on here, the SDK, which it's not obvious to me why I need a Copilot SDK. What is that for exactly?
So there is, in every single GitHub Copilot product, there is this thing called the agent loop. And that's the prompts, tools, context that actually is powering the experience you get in all these things. So traditionally, those had all been many different things. And then we built GitHub Copilot CLI. And so basically what the SDK is taking that thing that we do a ton of offline evaluation on, we work with the labs on to really make sure it's an awesome experience for everyone using GitHub Copilot. And we take the core of that, and it's an SDK. And so you can basically package that agent runtime from GitHub Copilot into any application.
Yeah, it's very cool. And if you're into these, like, is anybody out here using OpenClaw or Hermes agent, any one of these personally? Only one hand, wow. Okay, so yeah, that's been my experience as well. But one back there. So if you have a Copilot sub, you can use the SDK and you can basically one-shot your own assistant just to play around with it and see how it works. I encourage you to try that out there. All right, last question. You have 45 seconds. New coding model, MAI Code 1 Fast.
Yeah.
What is it? And is it true that it's better than Mythos?
It is the first coding model we built from scratch here at Microsoft, so I'm very excited about that. In the blog, we compare it to Haiku, so it is kind of, you know, in that class of models that's built for like fast, efficient work. So like a lot of the training philosophy for this model was how do we get this to be really good in GitHub Copilot, so specifically trained on GitHub Copilot's tools, agent trajectories, so that should give it really, really good results when using it specifically in our harness inside of GitHub Copilot. And there's a whole bunch of other efficiency things that it's also trained on, like it's supposed to dynamically control like its response, depending on the prompt you give it. So if you say, hey, it's not going to go on some diatribe, right? So it has like adaptive solution length training. Yeah, so it has all that going on. So yeah, I'm super excited. I mean, it's the first model that we've shipped for coding here at Microsoft from scratch.
Yeah.
We've had some fine tunes we've shipped before.
Is it really the first coding model?
I think so. Maybe there was one before, like in the early days, but within recent memory, we had like Raptor Mini, but that was a GPT-5 Mini fine tune.
That's right.
That wasn't something that was built from scratch entirely. So yeah, we're excited. Like, give it a try. Want to see your feedback. It's definitely like our first attempt in this space. So like it's rolling out in Model Picker right now for VS Code developers. You can also get it in auto. So if you don't see it, like keep checking back. We're rolling it out slowly, but we'd love your feedback.
Awesome. All right, well, thank you so much, Pierce. Round of applause for Pierce here. Please go see Pierce at his breakout session. It's over there on the floor. I don't know what the number is anymore. There it is. All right, see ya. Bye.
See ya.
Did you know you can use voice to text when prompting in VS Code? All you need is the VS Code speech extension, and it's a game changer to be able to just directly speak to kick off your agents. I have this VS Code community contributor website that lists some of the top contributors for the latest VS Code release. It has a feature where you can give kudos to contributors, and I think that this could use some confetti. To prompt this with just my voice, click the microphone icon in the chat input. Add a confetti animation when a user gets their first kudos. We'll send that prompt off, the agent will get to work, and in just a few moments, without typing a single key, we have that feature implemented.
All right, Tom, am I supposed to say we're back?
We are back.
We're back. All right, folks, as I was saying, director, Google Cloud AI, best-selling author, speaker on AI, developer experience, user experience, 𝗦𝗲𝘀𝗀𝗶cie.
You're very kind.
Thank you for being
here.
here.
Hi, folks. It's nice to be here.
So I told you I was watching a Bloomberg piece about AI, and you were in it. And I told my wife, I was like, I know that guy. She's like, no, you don't. It's like, I do. She didn't believe me.
She didn't believe you?
No.
It was probably for the best.
Yeah. But @𝗦𝗲𝗀𝗀𝗀, I've known you for a long time. You've been writing and making videos and speaking since way back jQuery days.
Oh my gosh.
Doing the web.
jQuery days.
Yes. A lot of web performance stuff.
Yes,
and now,
yes.
a lot of AI agents and skills.
Yes.
Yes.
Yes. A lot of agents.
And today we talked about you coming on and talking about you have a skills repo, which was on the front page of Hacker News multiple times.
I try
believe.
not to look at Hacker News too much these days. You never know if it's going to be good or bad.
Well, tell us about it.
All right. So today I wanted to talk to you about agent skills, and a lot of people here probably know what they are. But very quickly, I'm 𝗦𝗲𝗀𝗀𝗀𝗀. I work on a bunch of agent stuff at Google, so things like the Agent Development Kit, Agent Platform, and we work on a number of skills-related projects at Google. So we've been thinking about skills for a while. If you're not really sure what skills are, they're basically a standardized way to give AI agents new capabilities and expertise. And they've been a really hot topic over the last couple of months, especially as, do you remember back in the days when people would share their secret shell config, and there'd be a lot of files, and they'd be like, hey, these are my magic tricks.
Yes, dot files.
These are my dot files that work really well for me.
My magic tricks.
This is my bag of tricks. And you'd be like, I want that bag of tricks.
Yeah.
But then you think, well, my bag of tricks might be different than your bag of tricks. And so I think of skills in a very similar way. Sometimes you want to be inspired by other people's ones. Sometimes it's okay to just copy their bag of tricks.
Right.
And so I think there's going to be some stuff in here where people can just copy and take themselves. And sometimes there are going to be things here that will be inspirational. Now, just in case skills are not something you have spent a lot of time on, I thought it'd be interesting to just give people a very quick primer. And so I vibe coded this very quick, very silly Windows desktop in a browser. And I thought that I'd drop Clippy in here because I haven't seen Clippy. I haven't seen Clippy so much at Build.
We're not allowed to mention Clippy. It's a very
okay.
Yeah, it's very well. There
Excellent.
actually is a Clippy suit
There
that you
is
can
a
wear,
Clippy
but if you
suit.
wear it, you're not allowed to speak. True story.
Really?
Yep. Those are the rules.
Well, you didn't mention it, I did. So,
Yeah,
so we're
there we
fine.
go.
We're totally
You broke
fine.
us into jail.
I
All right.
broke you into
This
jail.
is weird because we have the Mac OS dock down here, but then the Windows above it. I like it.
It's bringing the best of all. This is just terrible. It's the
Quite
worst
cursed.
of all. The worst of all worlds. Okay, so if you're not really sure what skills are, basically there's a standardized way of packaging expertise and context that your agent may not necessarily have. It can package workflows, there are instructions for your agent, and the structure of them is kind of this. You have a name, you have a description. There can be a lot more content in here, but basically the name and the description are the main pieces that every single skill file is going to have. And these are repeatable. Typically, you're not going to have a skill for something that's one-off, because a one-off thing is going to be more like a prompt, but a skill is something that you or your team might be using on a reusable basis, and it might be useful across a few different projects. Now, skills load on demand. So you have a task that arrives into your agent, it will match it with a skill, it will load its steps, and then it will try to follow them. It doesn't necessarily need to know more than the name and the description. So agent skills, as you mentioned, this is a project that I created a while back, and for some backstory, I had been taking a little bit slower on open source for a few years. You and I have been doing a lot of open source for a long time.
Long time,
You know,
yeah.
a long time. As you know, you create an open source project, it's a lot like having a kid. You have to maintain it. And so you have to be explicit about like when you want to get an open source project out into the world. And it's been a while, so I thought, okay, I will get one of these things out there. I had seen that 𝗦𝗲𝘀𝗀 had put out GStack.
That's right.
Right? And I thought, well, you know, if 𝗦𝗲𝘀𝗀 is doing GStack and people are learning from it, there's nothing to stop me from putting my perspective on agent skills out into the world. And so I started this project, and it got some traction, and I thought, you know, it'd be interesting to maybe walk folks through it. My perspective on agent skills is, I would say, just a little bit different to other folks. I ground my agent skills around the software development lifecycle. I think that they're, you know, I lean very heavily into agentic engineering, AI-assisted engineering, that side of things where you try to be very disciplined about, you know, I'm going to be explicit about what I want built. I'm going to verify what gets built. I'm going to keep quality in mind. And so for my agent skills, I have a lot of steps that kind of map to the SDLC in here. So define, plan, build, verify, review, and ship. And for each of these different phases of the SDLC, there are a number of different skills that are inside this project that map in here. So for defining, we've got skills that can interview you to get clarity around an idea. If you have a very vague idea, so maybe you have, you know, you've had an idea in the shower and you're like, well, I kind of know what the outcome is, but I actually don't know what the UI is going to look like, or I don't know what the details are going to be. You've got a skill here that can help refine it into something more concrete. You can do spec-driven development. We've got planning skills for turning things into tasks. We've got building skills that can help you sort of refine this to a place where you've got very, very good front-end UI, your API and interface design is in a good place. And then sort of skills for a number of these other phases for verification, that's really important. You know, I think you and I have done a lot in the browser over time, right? I still build, I used to work on Chrome. I still build a lot of, you know, projects that will render in the browser. And so testing in the browser automatically with an agent these days is something that I care about. So I have a skill that will do that. Automated debugging is also part of this workflow. I've got a code review loop in here too. That includes things like code simplification, security, and then I've got ship skills as well that will help you with everything from your CI to your Git workflow, your documentation, shipping, and launch. Now, there are a lot of phases in here. I'm actually going to show you how these work, but there's basically a pattern that I use for all of my skills. There's an overview. I capture like when these things should be used. I have rationalizations, like why should this be used and why should this not be used, so the agent has a little bit of a guardrail that it can keep in mind. And then red flags as well, so that the agent knows if things are really going kind of off kilter. And then verification. So how do we know that we actually did the steps right and in a good job? Now, all of that stuff just maps to commands as well. So you can explicitly just use like a / command in Copilot, in any of your agentic coding tools, and trigger any of these phases. Now, you don't have to use, of course, my agent skills. As I was saying, they're a lot like your bag of magic tricks, your dot files. If there's something in here that's useful to you, copy it, steal it, you know, have it make you productive. If you find that the way that I do things is helpful, you know, you can go in and use it wholesale. But I wanted to just show you a little bit of this in action. So I've got a scaffolded out project here where I've installed the skills. We've got some agent files. We've got prompts for just mapping all of those skills. This is what happens when you just install it inside a project. And then we've got some of the skills themselves. And I'm over here inside sort of the Copilot sidebar. I've selected Gemini 3.5 Flash. I work at Google, I work on Gemini, so I'm going to be using Gemini 3.5 Flash here. It's a great model for agentic coding and for agent tasks. I believe that, you know, VS Code has also got like an agents view these days as well, right? So all of these commands, you know, you can just type in /. You will see that there are additional commands populated here through using the agent skills. And you can use any of these, so like things like refine, things like the code simplification, etc. But just so that we can see what's actually getting built out, I'm going to stick with using this view. And we can start off with maybe just even doing a quick look at our skills, and I'm just going to show you test-driven development. I was talking about, you know, maybe giving you a bit of an insight into what these files contain. Now, you'll see a lot of content in here. I try to be very diligent about what ends up in context windows. So again, if you feel that there is too much that is in here for your needs, you can always trim it back, you can always optimize it further, but I try to be very explicit. So for test-driven development, I capture the TDD cycle. I have a very explicit take on like, what does it mean to have a failing test? What does it mean to have a passing test? How should you think about refactoring? What are other patterns that I personally think work really well? Many of these patterns are ones that have been inspired by how we build software at scale at Google. And so I thought they'd be interesting to kind of encode inside these skills. So you'll see things like the test pyramid in here, decision guides. There's a number of best practices that are encoded in here as well. Lower down, you'll also see that I capture things like test anti-patterns, things to explicitly avoid, how to approach browser testing. So this is that connective tissue that can then take us back to things like browser testing, browser debugging. I tell it what to check. I tell it how to think about security boundaries where testing is concerned. You can be as explicit or open-ended as you kind of want with these things. I try to be explicit just because I think that there's value to being intentional with how you approach these things. Now, what I thought would be interesting, I've been someone that for a lot of my life has been trying to optimize my productivity. I think I've probably failed at it a lot. And so habit tracking is something that I look at now and then, right? I think a lot of people try to improve their habits and their systems. So I thought it'd be interesting for us to try building out a habit tracker. And maybe, if you take a look at, everybody's kind of looked at their GitHub contributions graph. Maybe we have a habit tracker that uses that kind of visual to show you like how well are you doing at following your habits over time. So what we're going to kind of start off with here is I'm just going to trigger the refine command. And the reason I'm going to do this is I have a raw idea. So I want to build out a habit tracker, right? So we're going to say just something like a habit tracker, GitHub inspired, and I don't really want a database backend. Maybe let's just have it all work in the browser. So store everything in the browser. That's relatively vague.
It's pretty vague. That's
pretty high level.
Are you going to say contribution graph, or are you going to leave that out?
I'm just going to keep it. I'm just going to keep it GitHub inspired. I could say contribution graph, but that's being explicit.
That is.
Right? So we're just going to go and trigger refine now. And so it's analyzing our prompt parameters. It's analyzing the core components of the request. It's triggering the skill. You can see that it's been reading that skill in place. Now, the first thing that's popped up here is it's asking me clarifying questions. So who is the primary target user? Great question. It doesn't know if this is just for me, or I'm building this for a team, or I'm building this for my family or my friends, or what. So the audience is going to be, let's say, a room of software engineers at Build, right? Or YouTube, because people are going to be watching this later.
So just anyone.
Just anybody. What are the constraints and expectations for browser-only storage? Great question. You could be using IndexedDB, local storage, session storage, lots of different options. I'm going to keep it very simple. I'm OK with local storage for this. Beyond the standard contribution grid, so here, it was able to figure that out itself. What GitHub analogies do you want to explore, like committing, a habit, branching, variations, pull requests? I don't want to go too deep into these analogies.
Yeah, I was about to say.
I think let's keep it simple with the contribution grid.
Interesting that it's leaning into that. It's
Yeah.
like it wants to make the whole
Yeah.
thing about GitHub.
And this is one of those things, if you take a look at how that skill is defined, it actually has language around trying to begin converging on the direction, the idea that you have, leaning into like, okay, well, I kind of get what you're going for. Let's keep going down that path. So what does success look like for the MVP? Because very often, if you define like just a high-level prompt, it doesn't know if you're trying to build out something for a startup or a side project at the weekend or what. So I feel like the performance requirements are good. Like all of this stuff seems good. I don't necessarily need it to be offline first with service workers just yet. So load fast, clean UI. That's about it. Load fast and have a clean UI. Be responsive. Okay, so we've got all of these answers now. Didn't take us very long just to start getting clarity around this, right? I didn't have to go writing a big spec myself or anything like that just yet. And so it's trying to read the rest of my project just now, trying to see if there's any other context in there. This is a fresh project, so there's not a whole lot that it needs. And here's the output, right? It has a problem statement. It has statements around like how we differentiate directions, think about stress tests, and it gives us a few directions we can take. So direction A is a dev profile configurator. So a very minimalist, high-fidelity clone of a GitHub profile that allows us to track habits the same way that you would GitHub repositories. There's a lot more detail in here. Direction B is more of a keyboard-driven habit terminal. I'm more of a...
TUIs are so hot right now. Yeah.
TUIs are so hot. Direction C is a markdown SVG exporter, so a plain text backend tool. Your habit configuration and grid data are represented. So this is more data. This is more like you really want to enter in raw data and manage that, which is not really the vibe I was going for. I think that the first one's probably the closest to what I had in mind. So I'm going to go with direction A. And you can also see that it's got other assumptions in here and pushbacks. So it's asking me which direction resonates the most. I'm just going to say direction A.
Did it recommend one? I couldn't see under the counter there.
So we can scroll back. Once you pick A, B, or C, I will produce one. It didn't recommend one. You can actually change your skill files to say, well, I want you to provide your own perspective on it.
Okay.
In this case, I'm trying to,
because I notice models like to recommend.
Yeah,
they almost always, when they give you choices, be like, well, this is what I do.
Yeah.
And then I'm like, well, if that's what you do, then that's what I want to do.
Yeah. Well, and sometimes I will ask the model, like, give me 3 choices and tell me what you think I should do, just in case.
Yes, but then I feel like I'm just always doing what the model wants. You know what I mean? I'm like, well, if you think it's best, then it's probably best, which is not true
I have
at all.
so much to say about cognitive debt and cognitive surrender.
That's right. Your next article on the front page of Hacker News.
So what we have here, so the app is called Streak. We have a problem statement. We've got a direction here. We've got some assumptions to validate, like what is the retention rate? What is like the frequency going to be around habits? What's the mobile usability going to be? Since engineer configure setups on desktops, but often complete habits on mobile, is local storage enough? Well, probably, yeah. Local storage is well supported everywhere at this point. So I think that pretty much all of these ideas are cool. So we have our MVP scope defined for us here. And it also says what it's not doing. So it's not doing cloud sync. It's not going to be doing advanced social features. And it's got some open questions for us if we want to provide clarity around that. And it also asks us, do we want to just save it? So I'm going to say yes, save it. So we've now taken a very high-level idea, and we've refined it. Now, the next phase of this is actually turning this high-level idea. So we've gotten it into a better place. Let's turn this into a more detailed spec.
Yep.
Now, for some folks, you might say, well, it feels like it's a few steps. You don't have to follow my way of doing things. If you want to just have like one step for creating your spec, you can do that. I just happen to like specificity.
So you like to plan, you want the plan, the spec, and then the implementation.
Yes,
okay.
yes, exactly.
I'm a plan implement guy myself.
Yeah.
I just skip over.
Yeah, that's totally okay. Everybody's got their own workflow. Here you can see the file that it's generated. And this is going to be a starting point and entry for the next step. So the next step is going to be spec. So we've got our idea. We can go and just type in /spec. And it's then going to read in the output from that last phase. And it's going to start being able to generate something that's much more concrete. So it's taking in those assumptions, is defining success criteria, scaffolding out the tech stack a lot more in detail, and then it's got those open questions in a little bit more detail
And that is really snappy.
Yeah, it's pretty quick.
That model is quick.
Use Gemini 3.5 Flash. Or whatever model is out at the time you're watching this on YouTube.
Yeah, because
AI moves fast,
24 hours, everything will be different.
Everything will be different. So we've got some open questions. Grid generation technique. Should we use a standard GitHub contribution grid? Do we prefer rendering grids as modular dynamic SVG group structure or CSS grid element layouts? I'm going to be honest, I know CSS grid. I use SVG, but I'm not an expert.
Yeah.
So I'm just going to, for one, I'm going to say, choose what you think is best. And then first visit boilerplate, what default habits should we set up for new visitors? It's a good question.
Oh, like bad habits? Or are we tracking bad habits or good habits?
We're tracking good habits.
Okay.
What are good habits we should?
Good habits, exercise, hydration, Reading.
Reading? Meditation? Do people meditate?
Doom scrolling.
Doom scrolling, okay.
Meditation probably better than doom
meditation
scrolling.
after you're doom scrolling. Okay. Do you have a desired location for this file? I'm just going to let it do what you think is best. Cool. What I love about this is all of this UI, all of these questions are directly inside of the Copilot sidebar. I don't have to use some other app for it. Whatever your agentic UI surface is, you can just have a similar experience there. So it's now created a spec for us. I'm going to keep this. And the next phase, you can go and you can take a look at the spec, by the way. It's over here. It's going to be a much more detailed version of that original file that we had. But you'll see that we have success criteria. We've got metrics in place here for performance, so things like largest contentful paint. We've got a tech stack that's defined. This is going to be very simplistic. So vanilla JavaScript, I didn't say I wanted something in React. I'm okay with
never
vanilla.
asked you about the tech stack, did it?
Yeah, it didn't ask me about the tech stack. And that's another thing that you can encode inside of your skills.
So this is an assumption that you just let it go with.
This is an assumption that I'm okay with. You can assume like it's defined Vitest and Playwright for our end-to-end testing, which I'm okay with, our storage, and then project structure and code style. And if there's anything in here that you don't like, you can always go back and either manually tweak it or work with your agent to configure this more. So you've got your spec now. The next thing that you might want to do is actually start breaking this down into individual pieces. Now this is useful if you've got a large project that you're working on. If you're working on something small, you probably just want to go straight into implementation.
Yeah.
But I'm going to show you this plan in action anyway. So we've got a plan step here. And what we can do with plan is, I can go and I can run plan. I'm just going to show you this working. And what this can do is help break down, what we say in software engineering often is if you've got a big problem, break it down into smaller pieces, right? And plan kind of helps you with that. It breaks your big spec down into granular chunks that can then be implemented. And that's really good if you're working with TDD because you've got very individual pieces that can be tested, verified as you move on to other pieces. People have lots of different ways that they like doing TDD, so I'm not going to assume that my way is the right way or anything like that. So it's going and it's scaffolding out the basic parts of the project right now because that's fine. Like it can set up our boilerplate before we actually go and start implementing the rest. I'm just going to do keep on that. And you'll see that it's asking, before beginning phase 1, I should initialize our structured to-do list to provide full transparency, and it's going to do that now. So what you're going to have here is the package.json file, which we see has been created. The implementation plan is established and saved to plan. So we've got a task list here. You see phases and tasks. So we've got phase 1, task 1, which has its acceptance criteria. And this is like build the pure logic TypeScript interfaces, your types, your functions, to compute the streaks, your total contributions within the last 365 days, the local storage pieces, basically stuff that doesn't necessarily touch your UI. And we've got some acceptance criteria here as well. So we've got a list of things that have to be true, as well as verification. So the test suite has to be able to run on that piece of logic in order to move forward. It also suggests what files are probably going to be touched as a part of this, just to really hone them down. If you've been doing any vibe coding or agentic engineering for a while, you know that one of the ways in which we try to limit our blast radius is by saying, well, I'm just going to target these specific files. Because especially if you're working on an existing project, you don't want it to start overwriting or touching files that maybe have nothing to do with the task at hand.
Yeah.
Right? So we have a few different phases and tasks here. Some of the other phases will include our data storage, so that layer for local storage. It'll include sort of the visualization of our habits as that GitHub style contribution graph, as well as the rest of our UI. So we've got our plan here. What you can do, again, this supports being very granular or not having to think about that in as much detail. So if I wanted, I could do something like /build task 1 and just have it do the first task on that list. So let's see what it does. It's created 4 to-dos as a part of that. It's evaluating it. It's reading our test-driven development skill right now. You can see that it's installing those first things. I'm also just going to do
if you go,
always allow.
You can do it down to the very bottom and turn on bypass approvals if you want to.
I'm learning something new. Oh, wait. I see what you're talking about here.
Right there, yeah. And then
Okay.
we'll stop asking. Are you a bypass approvals? Do you recommend bypassing approvals?
I bypass approvals on all my personal projects.
So now you're building one phase at a time. Is this generally how you work, or are you more?
I think it really depends on what you're building.
Okay.
So if I am building a personal side project and I just want to build something like maybe it has one purpose, I'm probably going to skip building out one phase at a time this way and just have it build the entire thing. If I'm building something relatively complex, I'm okay doing it a phase at a time. It might feel like it's slower, but the fact that you go through all of these steps and you know, well, this slice is tested. As we build out the UI, I know nothing else is broken.
Yeah.
I've now done our data layer, nothing else is broken. This gives you a lot more confidence as you're working through. It's just a different way of approaching this.
It's such a trade-off, though, because then the human's back in the loop. Like, once again, you're the problem.
Yep.
You're
Yep.
slowing the agent
Yep.
down.
Yep.
It's tough. I struggle with this myself.
Yes, absolutely. And I would say that you have to make a judgment call at the end of the day about how much time you want to invest and where in the software development lifecycle you want to invest it. Do you want to put a lot of time into your spec? Just have your agent build out a lot of code and then spend time reviewing it, defining your tests at that point, figuring out like, how do I evaluate quality? Like that can be okay as well. Or do you want to approach it with TDD in mind? Do you want to have like an explicit strategy around how you're going to verify quality so that as you're going through, it's already addressing these things? And I don't think there's a right or wrong way, it's just different ways of working.
Yeah.
You know what I mean? So what you can see with this first phase is that the implementation is test-driven. We have our first target failing red test to tell us that, okay, we have a test, it's failing. We're going to implement the minimal clean logic in streaks.
Oh, so we're red-green here, yes?
Yeah,
Okay.
yes. And as I said, you don't have to do this with like individual tasks. We can just keep running build to work through the rest of this. And then we can get on to other phases. So you can see that it is, thanks to Burke's tip around bypassing approvals, we're just going to keep running through this. And I'm a person that people will often talk about, how do you as an engineer understand what is getting generated if you're not reading all of the code?
Yeah.
Very often as your agent is generating stuff, what are you doing? Are you switching over to another agentic task? Like very often, I found myself doing that. And so I started to slow down a little bit. And these days I try to read the trajectory a little bit more. Like, what did it say? What was it thinking? Why was it thinking the way it was thinking? And is there any nugget of information in there that I can extract that just lets me know, oh, okay, well, that was the way I was expecting, or it wasn't.
mean.
You know what I mean?
Yeah, so it's interesting because I don't know what everybody else does, but I watch the agent work. Mm-hmm. Now, I'm not reading everything that it's doing. I'm mostly just staring at it.
Yep.
When I should be doing something else. When I'm just,
Yep.
I'm literally watching agents spin. But I'm curious, are you looking at the code?
Great question. So I generally, unless it's a personal project, because a lot of personal projects end up being throwaway things.
Yeah.
Oh, I have this need for an hour. I'm just going to build something and throw it
matter.
away. And in those situations, I'm very okay with saying, if I don't understand the code, the agent is going to go fix something for me. However, if it's going to be something I'm going to maintain for at least a few weeks or a few months, I generally go back and at least understand the architecture, and I try to read through some of the core files so that if I discover that the agent wasn't able to fix something or it goes off on a tangent, I am able to go back in and make fixes myself.
Yeah.
Very often, so I'm going to keep working through build and we can keep chatting.
Yeah.
So it's going to keep doing its TDD phases. As each slice gets implemented, it's going to go from red to green, implement the phase, and get everything done.
This is so interesting. I didn't even know about red-green testing until SpecKit came out. It was the first time I'd ever seen that. That's the idea of writing failing tests and then making them work. And I was like 45 years old. It's kind of sad.
You do not
what
look.
it is.
You do not look over 45 at all.
I'm not, yeah.
Yeah. Or 45.
It was yesterday.
It was yesterday.
Yeah.
Happy birthday.
Thank you so much.
So we're going to keep doing this. I also wanted to share a comment on this. I think that very often in the entire sort of agentic engineering diaspora, the industry paints very broad strokes about best practices. Like if you're on Twitter, if you're on any social network, very often the best practices for a solo founder or a small startup team will be shared. And
Yeah.
the best practices for that kind of team that are maybe don't have users yet, maybe they're working on an evergreen code base, those are very different to people who are working on something either legacy, brownfield, with a team. And so I think that it's important just to understand that there are situations where it's okay to just give in to the vibes and have the agent figure things out, and if something goes wrong, we'll just have the agent fix it. In other situations where actually understanding what's happening behind the scenes is still quite important.
Yeah, 100% agree. I actually, so what's super interesting about this is that I think myself and most people are looking for just tell me what to install that's going to make everything work, right? Is it agent skills? Is it superpowers? Is it GStack? Like, what is it? And the answer is, it might be some of any of those things, but your job is less about writing code now and more about building these workflows that actually work. And it's not always the same even for different projects within the same organization. So
absolutely.
It's a very, I don't know what to call it. It's not software engineering. It's not automation. It's, how would you even describe it? It's like we all work at McKinsey now.
I don't know. I acknowledge that agentic engineering, we're now working on a spectrum, right? And there are going to be times when we're vibe coding, there's going to be times when we're agentic engineering, and the more diligence you have to apply to the process, the closer you are getting to agentic engineering. And I think that at big companies, small companies, anytime that you're working on something that exists and has existing users, you owe it to them to care about quality, to care about not breaking things in ways that sometimes agents subtly do.
Yeah, 100% agree. If you're building a habit tracker, that's one thing. If you're shipping VS Code, you have to be pretty meticulous about not breaking that.
Yeah.
So we have about 10 minutes left here.
So what I'm going to do is I'm just going to skip ahead a little bit and just show you very quickly some of these other phases. So the agent skills package also includes a verify step. Now, what verify does is it's able to just check that the implementation as it has been done so far, whether it's complete or whether we've partially implemented something that can actually be used just yet, can run in a browser and actually do what it needs to do. So it's going to go and check that it's actually able to spin something up. Let's see if enough of it has been built that it's able to do that. So it's doing its npm run build right now. It's going to spin up its npm run dev. And we'll see if this actually works. So we have something that looks like a GitHub profile.
Where did you pull that picture from?
I have no idea.
Who is that?
The magic of LLMs.
That's someone, if that person's watching the stream right now going,
someone in the world.
Hey!
Hello, whoever this is. This could be like a non-developer as well. This could be a person that just likes to bake cookies somewhere in the world.
It just happens to be on GitHub?
Yeah, it just happens to be on GitHub. But it's opened up this browser directly inside of VS Code. It's able to run its checks behind the scenes to see, okay, well, is anything actually broken? If I interact with UI, does anything actually begin to break? And I think that this is very interesting. Like if you actually go to the prompts and you go to our verify skill, it will end up trying out the browser testing with DevTools skill. There are many ways to do sort of automated browser testing these days, whether you're using Puppeteer, Playwright, the Vercel agent browsers. There's a lot of different options. I'm not going to say there's a right one, but choose what makes sense to you. I just think there's a lot of really great tools these days for just making sure that your thing basically works. Whether you decide to kind of encode all of your user journeys and test them out very, very holistically is kind of up to you at the end of the day.
Web devs, as usual, have it better than anybody else, right? It's so much harder to do with native apps.
Now, for my skills, the review phase ends up being really important, and people have a lot of opinions about review. I tend to find, and this is something that I found talking to engineers at Google as well, we still have a culture where we tend to have engineers manually review code. Even with that, even with trying to bring AI into our code review process, having an agent do a local first pass or multi-pass is really, really valuable. Now, there are some people that will take this all the way to adversarial code review with very deep patterns. There are people who will have other models, like, hey, maybe I'm gonna use Gemini for the implementation and Opus or Codex for others. So you have a lot of flexibility here. There is, again, no right or wrong way. People will often decide these things based on vibes. But what you'll see is we have a number of different kinds of review checks that were done here. So what's working well? What's technically considered correctness? So all of the unit tests that were implemented so far appear to be, passing. We have no security issues, it seems. We're working with vanilla JavaScript. We of course want to avoid XSS issues or cross-site scripting, anything like that. Readability and architecture seems to be in a good place. Performance seems to be in a good place. This is a simple, application, and it also applies some recommendations. So keyboard navigations for that contribution graph makes sense, right?
Yeah.
That's not something that I had considered, and you might find that depending on the complexity of what you're working on, that you can have this be much more elaborate. Another part of code review that I find useful these days is code simplification. Now, very often what we'll do is we'll have an agent implement something, we'll verify, maybe you'll read the code, maybe you'll verify that, hey, it at least runs in the browser, or if you're building a native app, hey, it at least runs. But you don't necessarily go back and ask yourself, hey, could this actually be simpler? And one of the wonderful things about TDD or having tests or quality gates around is that you can now go and do that code simplification loop and have something that can verify the rest of your logic still works.
Yeah,
right?
Very interesting. So a question on the security one. How much do you trust the non-deterministic? Because to me, this is where the rubber meets the road, right? The rest of this stuff you can deal with. The security stuff cannot. How much do you trust that review that you're not pushing a key, you're not pushing some SQL injection, something that's just going to get you in a ton of trouble down the road?
Oh, yeah. I think that there are a lot of good open source and commercial offerings that go even deeper into security than these skills do. And so there are a lot of things that, we've seen, anybody that's been doing vibe coding and genetic engineering for a while has run into these issues, right? Very often people will be using API keys in horrendous ways, right? They will be quickly putting together something and not realize that, oh, hey, wait, there are actually tons of data leakage issues, or the way that auth is implemented is leaving you exposed to all kinds of problems.
Right, or somebody can just nail your API over and over again because it's not locked down.
Exactly.
Yeah.
And if you're a senior engineer, if you're experienced, you know what to look out for. If you're intermediate, if you're not quite as technical, if you're coming at this without as much of that background, or maybe you are an experienced engineer and you're just lazy, because sometimes we are lazy, it's useful to encode those things in skills just as a sanity check for yourself.
Oh, actually list specifically?
Yeah.
So I find that I cannot think of all the edge cases.
Yeah.
But models are actually really, really good at this. If you ever ask a model to review a code base, it will almost always find something that you need to change or improve.
Yeah.
Right? They're really, really meticulous and good at that. So yeah, again, I don't know. I feel like we need maybe better products or whatever it is, but all of this, to me, agentic code should go through some deterministic gate that's yes, security sign-off has been achieved, because I don't trust, I'm scared to death to push anything live on Twitter and be like, here's what I built, and then have somebody be like, oh, and here's your Gemini key.
And I think that's where there is a lot of value in understanding what does good mean, what does done mean, right? And if you care about security, you care about quality, you care about performance, you care about accessibility, you care about any of these things, that's a good reminder to try encoding those into how you approach quality gates in your projects.
Yeah.
Skills are just one way of encoding that into how you think about all this stuff. But I think that just having tooling in place to make sure that you're not merging in code that's going against those best practices is always a good idea.
Yeah, I feel like we need more of these deterministic gates. I just don't know what they are. Right now, Markdown is the solution to everything. It's well, we have non-determinism. How are we going to fix that? With more non-determinism.
With text files.
With text files. So we're at about 6 minutes here. I'd like to do some Q&A. If we could, you can continue building.
So I'll wrap this up in a minute. So there are a lot of great teams, labs who've been thinking about code simplification. And very often what I love to do is anytime that they open source their work or they write up a blog post about their work, I go and study, is there something that I can learn from what they're doing that I can then incorporate into my skills or how I work? You can do that for code simplification as well. Even for this simple app, it's already found 3 or 4 opportunities to simplify the code. So that's great. We've got a ship step in here as well. Just for time, I'm just going to skip ahead and show you one that I built earlier. This is called Streak. It's got a GitHub contribution graph style,
Very nice.
graph at the very bottom. And it just shows us over time, like, are you actually following some of these best practices? So for me, am I going screen-free for some portion of the morning? Am I, getting my workday goals planned? Am I reflecting? So you can, this is not a complicated app, but you can pop open, your browser DevTools. You can go into the application panel, local storage, and we can see that all of our data is kind of here. We've got all of our entries for each of these things. It's all local. It all works. Like, all this will work offline, but it does the trick. Now, we can do Q&A.
You want to do Q&A?
Yeah,
Let's
we can
some
do Q&A.
So let's spend a few minutes. Do we have a, Tom, how do we do this? Do we have a mic, or if we're going to do Q&A? Oh, right there. Yeah, so if you do, we'll continue building here. If you want to ask questions, now is your chance to do so. In the meantime, we can continue building or chatting about skills if you want to. It's up to you.
Awesome. If folks have questions, I'm happy to take it. Otherwise, I'm happy to keep showing you stuff.
All right, we got one. It's Anthony.
Hey, yeah, question for you. How would you split up the work between like a Flash type model and a Pro model? Would you plan in Flash and then implement in Pro? How would you split the work?
Did you hear that?
Yeah, interesting question. So how do you split up between models? Like, do you plan in Flash and then implement in Pro? Like, are you multi-model between the Gemini family? Like, what's your personal take here?
Yeah, that's exactly my workflow. I tend to, and especially if you're trying to optimize for cost, that's a great way to go about it. You can use a lower cost model often for the planning phase, especially if you're trying to optimize for tokens. Use a lower cost model for the planning phase, use a much more capable model for your implementation. And whether that's going to be one of the Gemini Pro models or Opus or Codex, any of those options can be good for your needs. But I found that flexibility works well. And Copilot and many other tools also let you just easily switch between different models for these needs and these different phases,
yeah.
which is great.
Interesting. I have a question for you. Where does MCP factor into this workflow?
That's a great question. I have too many strong opinions on MCP these days. I think that
let's do it. we actually have some extra time, so we can go over a little bit.
Right. I personally think that things have been moving so fast, right? And earlier on, we would talk about the difference in, hey, MCP was really good for, the connectivity, right, between data and agents and so on. And I think that people found that very often there are cases where you actually want a CLI instead of an MCP. And we've started to see workflows begin to evolve a little bit more because maybe you don't need to have so many tools exposed. Maybe just directly using a CLI is going to be a more efficient way to achieve your goals. So I personally feel like we are still in that kind of evolution phase of seeing okay, well, where is MCP going to be the best fit versus just having people directly use the CLIs for things?
This is kind of a contentious area, I feel like. Because at one point I did say your MCP server should probably be a skill and a CLI.
Yeah.
I kind of still stand by that just because AIs are so good at using CLIs.
Yeah.
The only rejoinder I have to that, I was chatting with Reese, who I think is over at OpenCode now, about this on X, and he pointed out that the authentication is a real problem, and that MCP does this really, really well. And with CLIs, it's really hard to control auth and permissions for your agent. So I agree with it, but generally speaking, I almost use entirely skills. The only MCPs I use is, of course, WorkIQ, right? Because if you're in the Microsoft ecosystem, that's the best thing ever. And then Context 7. I always talk about
Context 7 is great.
It's amazing.
It's so good.
If y'all aren't using the Context 7 MCP server, that's the one thing you should install today, and just tell your agent, always read the docs before you do anything, and it will use Context 7 to read the documentation. It's brilliant.
I love that, even in Google Cloud, I know in lots of other places, people have started to release and maintain more skill packs just because you can get so far these days with making sure that regardless of what cutoff date your agent's data is going to be, you've got up-to-date documentation, up-to-date instructions about where to go, where to find things, exactly what the developer workflow should be. So I'm a huge fan of skills. People don't know that by yet.
Yeah, they're amazing. And the other thing advantage, you talked about this early on, is they're loaded progressively, right? So one of the things we're all struggling with right now is that the context window is a problem. And honestly, I feel like we need a better solution than a context window in general at some point in the future. This is like a really rudimentary primitive for interacting with LLMs. But the problem is that the context window fills up really fast, and MCP has to specify all the tools. So if you didn't know, skills are progressively loaded. So what the model gets is like the skill name and a brief description, and then from that, it then will load in the skill, and then the skill may point to other files, and then it will load in those files. And so it's just really, really economical for token usage, which is more important now. It's becoming more important every day as we are moving from a world of use as much AI as you want to this is how many tokens you have, use them wisely.
Absolutely.
All right, well, Addy, thank you so very, very much for being here. I learned a ton. I was looking forward to it just for the free training on your skills repo, so I got something out of it. Thank you for being here.
Thanks for having me.
Appreciate it.
It's great.
All right. Thank you so much. So we will be right back with our next guest, and I guess maybe folks can come chat with you if they want to.
Sure thing.
All right.
Thanks, folks.
There we go.
We have an SDK. It's available in Node, TypeScript, Python, Go, and .NET. And you can use this SDK for multi-turn conversations, tool execution, and full lifecycle control. Now, this is in technical preview, but already we're seeing people build some really fun stuff with it. Beyond that, there are some great new features that have been added to the GitHub Copilot CLI in the last few weeks, including access to more models, built-in custom agents for things like Explore, Task, Plan, Code Review. And then you can use those custom agents with agent skills to have a really robust workflow. You can also install the CLI now via Homebrew, Wingit, and there are install scripts. And if you install any of these methods, then Copilot CLI will automatically update, which is great. But don't worry, we still have standalone releases if you're needing that because of your distribution or however you want to get things. There are a bunch of new flags for using the Copilot CLI in scripts. There are improvements to the diff view, there's some web controls, there's lots and lots of stuff. So if you have not had a chance to play around with the GitHub Copilot CLI, give it a shot, especially now with the SDK. It's getting really good, and the team is working really hard on adding stuff to it all the time. We are also actively seeking out your feedback, so if you have any thoughts, any wish list items, feedback, let us know. You can let us know in the comments of this YouTube video. Let us know, on social media. Create an issue or post a discussion in the repo.
Hey, what's up, everybody? Welcome back. And we are here at Build 2026 live in a vast open area. And I'm here with Patrick 𝗦𝗲𝘀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀𝗀😂
Yep, CLI SDK team. We're one big team. We're one big team because we ride on the CLI server.
Your mic is really, I can hear you better than I can hear myself. That's amazing. Yeah, so for those of y'all watching at home, we're in this vast, what even, do you know what this was before?
No idea, honestly. It's a beautiful building, well set up, but no idea what it was.
Yeah, it looks like it's like an airplane hangar. Yeah. No, it's not wide enough, is it?
Maybe anyway. A boat,
Yeah, we're here.
A boatyard.
All right, so we're going to be talking about the Copilot SDK today. And this is something I've used extensively, and I love it. This is one of these things where it's specifically for developers. Like, once you see this, you'll be like, oh, man, that's amazing. Yep. I can do anything. So take us into it.
Yeah, wonderful. Well, we just GA'd the SDK yesterday, which is fantastic because we've been working on it since January this year.
Just GA'd?
Just yesterday.
Okay.
1.0 stable. And so we've been quietly working internally, mostly to drive up quality and also make sure teams across Microsoft, LinkedIn, Xbox, GitHub, we can all adopt the SDK and we can use a shared agentic harness together as much as possible.
Nice.
And so that journey internally is now going outward. We're GA, which means customers can use the SDK, it's stable, they should stick it in production, can support it in a wide array of environments, and we're here to help you put our harness in whatever solution makes sense for you.
Awesome. So do we have any demos or anything we can walk through in terms of looking at how this actually works?
Yeah,
this is one of those things where when they first told me about it, I was like, I don't get it. And then I actually used it, and I was like, well, that's incredible.
Yep. I'll show probably my favorite use case, because it's very personal.
Okay.
Even though it's the same SDK that's rolling out in things like Office Excel right now and CoWork and Copilot Studio, as an example. Oh, yes, I can actually bring up a quick slide to just highlight a lot of the collaboration that's been happening across literally dozens of teams, hundreds of people, all the people on the ground building these products across these different solutions we've engaged with, learned how they're trying to adopt agentic solutions and modernize using the Copilot SDK. It's been
So
wonderful.
just to clarify, when we say Copilot SDK, what do we mean there exactly?
Yeah, so the Copilot SDK, it actually comes in 6 languages, which are right here. So there's the 4 we released at technical preview in January. There's the 2 that we've added since, which is Rust and Java. What it really is a thin client that sits over the Copilot CLI server that we've all known to grow and love over time.
Yeah.
And it's the same exact CLI server that's used in things like our GitHub Copilot app. We use the CLI very hands-on, and the SDK is yet another way to consume the CLI, but in a way where you can integrate it into custom applications.
Yeah, so the way that I thought about it was it just basically allows you to add the agent that's in the Copilot CLI to any application.
Yeah, and we really mean any application too. I mean, there's a lot of things that we're doing beyond just what was shipped in GA. We are rewriting our runtime in Rust, so it can actually go in more places, more performant.
Okay.
All of those things are on the horizon and in flight.
Wait, the SDK runtime?
The SDK runtime, yes, correct. So we're making it more performant and we're optimizing it. It's another piece that I showed off yesterday during the session where we just highlight.
Was it Node originally?
It was all Node.
Yeah,
so when you talk about loading up the CLI server, it's probably 100, 120 megabytes of RAM that it's using up.
Yeah.
We're trying to shrink it to sub 10 megabytes for the most part, and we're destined to get there for the most part. We have run some earlier tests and things like that, which show the difference between Node and Rust. And even while this was a POC, it was a fully working runtime. I can actually show you in a different demo as well. But the main core outcome of that is that we just saw benefits across every performance dimension that we cared about. And then there was also the need to actually get our SDK into more platforms that require a native runtime.
Right, gotcha, interesting. That's phenomenal. I see Rust popping up in so many places now.
It is. It's a very good language for agents.
The other day I was building some of the Copilot CLI and I said, how should I build this? And it was like, I would do it in Go. And I was like, but I don't know Go. And then I remembered, that is irrelevant. The agent knows Go. And so I built the thing in Go because I could.
Absolutely. And I think that's what's really amazing is it's pushing the teams inside of GitHub to think beyond the boundaries of their experience. Fundamentally, just the environment has changed, and we recognize that probably 6 to 7 months ago, and we've been really internalizing what that means for ourselves. And so when you look at the Copilot CLI and SDK team, we fully embraced very large experiments. We fully embraced seeing what the technology can do. It's one of the luxuries that we have at GitHub to just burn a ton of tokens to really see what the limits are of the models themselves.
Best perk of the job.
Honestly, it should start as a line item in the modern era because it is the biggest cheat code in general.
This is going to become like health insurance, right? Like you have how good is your health insurance, but more importantly,
how many credits are you getting?
How many tokens do I get in this
Exactly. Mainly because you can just shorten the gap between idea to outcome.
Yeah.
And when you don't feel as token constrained, you can go test those outcomes much more.
I hate it, man. It's really, really bad when you have to, every decision you make is based on like, well, should I spend these tokens in this way? Do I really want to use Opus here? And it really constrains your productivity.
Absolutely.
Do we have any demos that we can see on the SDK?
I'll show you one of when we shipped the technical preview, it was a technical preview, so we didn't expect it to go into like production grade applications at the time. So we saw a lot of personal assistance, and I use one of my own, of course, being that I work on the SDK.
I made one. That was one of the first things I did.
Multiple flavors, but I actually have really just been loving my current form because I'm a PM. And one of the things that's really essential to being a great PM is you have to write all the time. And so I think coding tools are awesome. They're wonderful. But really like this desire for a great way to write, deploy agents to support me in that action is where I'm currently at in my trajectory and what I'm really obsessed about day to day.
Can you show it to us?
Yeah, absolutely.
Because did you use this? Because we were working on something together and you did a write-up and you sent it over to me. It was like, I did a one-pager and I read through it. I was like, that's really good.
Exactly.
And you used your agent for that.
Exactly, yeah. And I call it whim because I want everything to be at a whim, which is why, for example, I can hotkey it anywhere I am in the system. You can leave it up, you can pin it, you can resize it. But really, the core of it is that when you are thinking about being a PM and you're putting things on schedules and you're trying to really encapsulate the job that you're doing and then transform it into something that's repeatable, I only really need kind of spaces to write. I need little workers, and I need skills. If I have those 3 things, you can accomplish sadly enough, a whole range of PM responsibilities. And I find that it's more fun than ever to ideate, think about the right thing to do. And so it's all canvas-based. What I mean by that, similar to what you see in the GitHub Copilot app, where we're exploring ways to render content and make it interactive, this is the inverted version of that, meaning you start with the writing canvas and you spawn all your agents out of it directly. And so what I love about this is inside.
Wait.
Yeah.
What? You're going to write up the file first and then spawn the agents
it's
from
simpler than that.
You're not going to write anything.
I'll actually just highlight first that there's a variety of agent personas in my Win app, which allow me to, one, run my agents in ephemeral cloud environments. I can now spawn an infinite number of workers, not worry about my local machine. I can close my laptop. I can pick up and resume whenever I want. That's one version of an agent I can use. There's my development agents, where just by calling it into action, it will code for me. It will develop. It will check out repos. It will modify. It will do all of those things you would expect. And then I have my editor, which is my main agent that I use because we're always working on the content. And then the last piece is my sandbox. If I want to run something local, it's a bit dangerous, I can deploy this agent and I can let it run it in a nice, secure MXC sandbox that we shipped yesterday as well. But when it comes down to the action, right, there's intent and then there's the outcome. And normally there's a whole lot of steps in between. And in reality, what I like to do is shorten that as much as possible. And so when I think of things I need to do today, I just start building a list like most humans do. And I'm like, well, I need to triage Copilot. Just actually spell correct, Copilot SDK, GitHub issues. And then I can just say, editor deploy.
Oh, you're tagging the agent there.
I've actually put it already in motion, and I don't have to think about it any more than that. And the way that it actually shows up is you'll see it present in the document. You'll see that the session has been fired open right here. I can actually drill down into any of the chats. So as I deploy the agents across my canvas, I can actually check on what they're doing. If I care about what's happening across canvases, I can get that view as well. You get similar controls, so if I want to turn these into sessions I can remote into, I can just click a little button, it'll give me the remote link, I can dive into it from my phone so I can pick up on the go. You have, of course, things like YOLO mode, because I like to run unconstrained.
Yeah, I see it's asking for approvals right there.
And you can continue to drill down a little bit deeper. So this idea of multi-agent orchestration, not really feeling like multi-agent orchestration, is where I think, in general, we're all headed, because there's a lot of cognitive load we're all feeling.
Oh, man.
And so when I think about the way I engage with people, how do I weave agents in to feel as normal and as common as how I communicate day in and day out?
Yep. So I had the same thought where it's like, I don't want a coding agent, I just want an agent that's everywhere that I am. So if I'm in Outlook, it's the same agent. It knows I was chatting with it about code. Now I'm chatting with it about email, right?
Exactly.
We don't need an agent just for coding.
Exactly.
But this is interesting. I've never seen a modality here that's not a chat.
And the nice thing is you can close these things out, and I rarely go into the chats anymore in this thing to begin with, because the output actually ends up back on the canvas. So I'm communicating through the canvas with the agents themselves, or they're off doing work and they'll open a PR, whatever it might be. And if I open up my Vim workspace, you'll actually see me working on Vim in Vim, where I'm like giving it bug fixes, sending it off, it's opening PRs, and it's just updating my canvas. And I think what's really beautiful about that is the record itself is being built as I'm doing the work. And so at any point in time, I can reflect back on that, I can roll that up, and I've already encapsulated what I've been doing and how it's been done.
Man, that's super interesting.
Yeah.
There's so much, the thing that's so irritating right now with AI is there's so many people talking about their like I have, I got OpenClaw and it's running everything in my life, and you're like, well, what's it doing?
Yep.
And they're like, everything.
Yeah.
You're like, yeah, but what? And they're like, all of it.
Yeah. It's fun though,
Like, but then you're like, but I don't know what all of it is.
Yep.
But so it's interesting to see like how you're actually using it. You know what I mean? Like it does feel like it's snake oil sometimes to me.
Yeah,
where
absolutely.
people are like, I use it to automate my job, but they can't tell you what exactly it is that they're doing.
Yep.
There's so much of that going around.
A little semblance to a few other industries in that light, in terms of making sure that we ground it in real use cases. They're easy to communicate. People understand them. I think that's really important because the technology is very generalized. Yeah.
100% agree, but often you have to build your own
100%.
in order to realize that, and that's what the SDK allows you to do.
Oh, definitely. And to build something like this, it used to be a tremendous amount of work, and now you can spend a weekend talking to your agent and get a whole lot of distance. And we continue to pack more capabilities in the SDK that make all of this just tremendously much easier. So things like remote didn't exist
That's
until a
right.
few weeks ago. The ephemeral sandboxes in the cloud is yet again another way for you to break free of some of the constraints that are
Can
available
everybody
locally.
use those now?
Yes. We ship them. The cloud sandboxes are in preview, but they are available. They're in there and they can be used, as well as local sandboxes were shipped in preview today or yesterday as well.
Yeah, so again, for those watching online, those are here, of you who are here, like if you're interested in, like how can an agent how can I use AI to do something actually useful? I would absolutely start here and use the Copilot SDK, if you have a sub, to build your own personal assistant, to do what you need to do. Forget about what everybody else is doing. Forget about installing something that's just gonna magically work out of the box. Build your own that works the way that you wanna work, and start just trying to automate the simple things that you're doing throughout the day.
Yeah, absolutely.
Like for me, that was the most transformative thing, was when I built my own that works how I work.
And I think it's like you're getting at a really interesting insight, probably one of the greatest, which is that we all have to build intuition for how the models perform and they behave. Similar to when you engage with a person, you're trying to understand the nuances of other person themselves. And trust is built over time. And then that intuition scales across models. You can understand how to deploy them and leverage them. But it's really important to dive deep. And that's why I love starting with Copilot CLI. It's like the simplest way to go straight into a model, get a very pure experience. You can scale that up to the GitHub Copilot app, which will give you cross-session, multi-agent orchestration. But I think diving in and really understanding the parts and the bits using the SDK will help you go an extra distance that's truly valuable.
And there's something that's so rewarding about building your own agent. Even though it is the CLI harness, but because mine's called Max, and Max is like I have a repertoire with Max. I know Max, Max knows me. That's probably some sort of psychosis, isn't it?
A little bit.
I need help.
I mean, you have to lean in a little bit to the psychosis to embrace the capabilities that are available there. Yeah.
Amazing. Okay, Patrick, one question for you.
Sure.
What's your go-to model? What's going on behind the scenes here? Which one are you going?
GPT 5.5 these days has honestly been really great, and I was somebody that sat on Sonnet and Opus models for almost a couple years at this point. But I find there was a nice balance, especially between the two classes of models. And so I'm a big, let one model do the implementation, let one model verify. You get a nice mixture of answers and responses to balance it out. They all have different training data and inputs that help them decide what the right thing is to do. And so I find GPT 5.5 is really great, especially for reviews. Still love Opus for generating code as well, but I've started to use GPT 5.5 pretty much exclusively the last few weeks or so.
So I've had the exact same experience. I just recently posted about this, but I'm mostly on 5.5 now. Opus, to me, still use that for like design and creative thinking, but for implementation and actually executing, I'm a 5.5.
Yeah, absolutely.
Well, Patrick, thanks you so much for being here. You got any other sessions?
I do. It's 4 to 5. We're giving a Copilot SDK session where we'll talk a little bit more about the great work we've been doing across Microsoft, what's going on right now.
Where is that? Is that here in this?
Should be in Breakout 1.
Breakout 1. All right. So if you want to know more about the SDK, Breakout 1 at
4 o'clock today.
4 o'clock today. All right. Thank you so much.
Perfect. Thank you, Bert.
Thanks for being here.
Cheers.
Right. We'll be right back.
I'm Ori. I'm a senior product designer at GitHub, and I help to design the remote control sessions with Copilot CLI or VS Code on GitHub Mobile. You get to start work on your computer, and then you can remotely connect to it on your phone and work on the go.
I'm Josh. I'm an engineer at GitHub. I've been getting all of GitHub's agentic offerings speaking the same language. One of the things that has enabled is remote control.
I'm able to stay connected and kick off new tasks with Copilot CLI, respond to it, and have it continue my local work. You can have multiple agent sessions going on at once. You can actually see all your sessions in one view.
Remote control enables me to check on the progress of my work and direct that work while I'm not at my laptop.
That frees you up to do anything you want.
You don't have to stay close to your desk to stay close to the code.
Things when you do Git operations and it purrs. It's like it was a cat, but then someone wanted goblin mode.
Oh, are we on? Are we live? Oh, thank you, Tom. What's up, everyone? Welcome back. Welcome back, folks. Folks who are here and at home. I'm here with Evan Boyle from the Copilot CLI team and a huge fan of fish. Fishing?
All things fish.
All things fish.
Yeah.
Evan, what is it that you say you do here at GitHub? GitHub?
Yeah.
At GitHub, yeah.
At GitHub. So I'm an engineering manager, but I'm a very hands-on guy. I don't think that you can build dev tools and be a manager in that space without writing a lot of code yourself and like living the life of your users. So my team builds a bunch of things. We build the core agent loop that powers the Copilot CLI and the SDK and increasingly all of the agents across Microsoft and GitHub. So that agent loop and runtime, the SDK, the Copilot CLI, and newly, the GitHub app.
Yes, which we saw in the keynote.
And
And by the way, Evan was with us 3 nights ago when we rewrote the whole demo from scratch.
At GitHub HQ until midnight.
Until midnight. Interesting times. All right, so we're going to look at the Copilot CLI today. I was actually on the bus coming over here this morning.
Yeah.
And was talking with someone, and the person behind me tapped me on the shoulder and said, "What is the Copilot CLI? I keep hearing about that, but what is it?" So maybe we should just start there.
Yeah, we can totally start there. So I am in the Copilot CLI right now. I just did a talk with Cassidy, and we created this repo here. And so this repo, basically, we asked people to open issues to decide what we were going to build live during the session. Pretty fun stuff. Got 60 issues open. And then with the Copilot CLI, what we did was we asked it, hey, go read through all of these issues. If you shift tab here inside of the CLI, tab, you can see all of the open issues. You can see all of your open PRs. And so we had the Copilot CLI go analyze all of those issues, pick out the best one, and then we went to go implement it. So what the audience asked for was this little octocat that was going to sit here and shower you with emojis when you did Git operations.
Just any Git operation.
Any Git operation. So we fed that issue into plan mode, created a plan, and then let it go on autopilot. And so it built this initial version, and then we asked, hey, audience, go open up a bunch of requests for ways that we could improve this. And somebody asked for goblin mode, which is what you could see here right now.
Is that because GPT was talking about goblins a whole bunch for a while? They fixed that?
They did fix it. They put out a really interesting paper about it, actually. Yeah.
I would like to know why that is.
And so we actually just got to the point that we had, so we picked out 5 features: goblin mode, sounds, eyes following the cursor, visibility.
Wait, eyes following the cursor? Does that work?
Oh, that one didn't make the cut, I guess. And then slower animations. Okay, so I think what I'm going to ask right now is instead of opening a PR, I'll do this with voice too. So I'll hold down the space bar, see this little voice meter pop up. All right, instead of opening a PR, I want you to just push directly to main.
That sounds like a great idea.
Hey, this is my repo. It's my personal repo, so
just force push to main.
I don't do that on our team repos, but for this one, it's okay. And I'll turn up the volume here and see if we can hear. So the goblin here, the goblin cat purrs every couple of seconds, and then it meows when you commit. Shipped it. There we go.
Nice.
So this was an Electron app that we created with the audience in the course of 20, 25 minutes.
Very nice. $1,600 worth of tokens.
I don't think that many. No, only this is like $5 or $10, I think, something like that.
That was all it was?
I got to do the math, but 1,300 credits. I don't know what that converts to.
Okay, so on the CLI, I have a question.
Yeah.
Why am I in a terminal and not in an editor, Evan? Why do I need this exactly?
I think the nice. Oh, there we go. It's making noises at us. I don't know if you heard that.
No, I can't hear.
So yeah, I think the terminal for me brings an awful lot of focus. There's no distractions. I can see the logs. Also, it's kind of fun to feel like a little bit of a hacker, right?
Yeah.
So it's easy to multiplex these things. I can use tmux and run multiple instances. If I have a big monitor, I can cascade multiple of these across my screen. And we've even turned the CLI into, like, if you like working in parallel, but you're working on a small monitor like this, we now have this /new command. So /new lets me start a new conversation. And so I could say, like, go do some research on open issues that we might want to address, right? But then I can go to /sessions, and I can see all of my other running sessions in this instance. So the Copilot CLI can now manage multiple sessions in parallel, have all of those tasks running, and you can switch between them. So if I go back to this original session, all right, it's live. Now I'm going to ask it, hey, go close out those issues we implemented, add a friendly message and a thank you to our community members. Cool.
So wait a minute. So when you do new /new, it starts a new session.
Yep.
But the other one, it sort of backgrounds.
It backgrounded that existing session, and I can see everything that's going on in parallel and switch between. So hey, I trust it to go and close out these issues. I'm now going to go back to my research session, right? So research open issues. Crawling through the issues, reading my README, right?
But it's super interesting to me though, like, why are we back in terminals? Why are we here?
Why are we here?
Because I agree with you. I don't know if how many people have used like CLIs here recently to do coding and development? See, like, look, there's not a lot of folks, like a couple hands here, but how many people are using editors and agents? So if you haven't tried using a terminal and a CLI because you're like, why would I do that? It's because it's a magical experience, and I can't put my finger on why that is. My preferred method of working is with Visual Studio Code open and the terminal as an editor tab, because you can do that, and I'll have multiple of them. That's how I work now.
Yeah.
The terminal just feels so good, and I don't know what it is.
It does, and I think that, you know, for a lot of people who haven't tried terminal coding agents, like, for me, I've never been a Vim or an Emacs person, and I know that when you think terminal, you think, oh my gosh, I've got to learn a ton of hotkeys, it's going to be complicated, I'm going to be stumbling over myself.
Yeah, that's exactly what I think.
That's what people think, right? But, you know, TUI applications have gotten so rich that they almost feel like a web app, right? They feel much richer than they used to. Like this, you know, this view that we have up here with issues, with pull requests, with gists back to my session, like it begins to feel more and more like a full application, almost like your IDE.
And I've noticed that there's actually less keyboard shortcuts in the terminal than there are in Visual Studio Code.
That's true.
Which is weird. And also, someone the other day was like, I want to click on the tabs at the top, and I thought, well, you can't do that, it's a terminal. And then somebody was like, no, we already let you click on things, we can make that work.
We can't, oh, and it does work.
It does work, they shipped it.
We implemented it.
Amazing.
So this is this is one of the things that's really funny about working on a team that is so heavily bought into AI. I mean, you can imagine the team at GitHub that is building the AI tools is the most AI forward, utilizes AI the most. And so it's been a couple of months since I did I think back in March, I did a survey, and with 10 people, we were shipping 2,000 PRs a month across app, CLI, SDK, agent loop. And so every time I come in contact with the CLI code base, I have to assume it's completely different than a week ago. If I built a feature a month ago and I come back to add something to it, I have to rebuild my view of the world because the velocity of this code is so high.
Yeah, moves so fast.
Yeah,
I was talking to 𝗲𝗲, who built the new UI here, and I was asking, I was like, how much agentic coding do you actually do on the team? He's like, well, I don't know what everybody else does, but I do a lot.
A lot, yep, a lot.
Yeah, very interesting. All right, let's talk about some of the other features of the CLI here. What are some of your favorites? Because a lot of them are behind slash commands.
Yes, a lot of them are behind slash commands. So I'm going to go ahead and start a new session. And we'll go ahead and do it in here. So I'm going to bump up the font. I'm going to run Copilot. I'm going to do it in YOLO mode. I don't always do this, but for the sake of demos, I want all of this to kind of stream while I'm working. So one thing that I really like to do is /review. So this is multi-model code review. And so what I'm going to say, I'm going to dictate here. I'd like for you to do multi-model code review with Sonnet 4.6, GPT 5.5, and Gemini. I'd like you to then compare the results and only feed me issues where the models are in agreement. Cool.
Is agreeance a word?
I think I just made it up. Agreement.
I bet it understands it anyway.
It'll understand it. That's the beauty of LLMs is they pick up what you're putting down.
And they don't care about spelling at all.
They don't care about
I frequently
spelling.
watch people type and they'll be like, "Oh, I misspelled that," like backspace. It doesn't matter.
I just mashed the keyboard.
Just
for sure.
Just send
Yep.
it. It knows.
And so let's see. Oh, this is really cool. So this is what's called elicitation. When the CLI detects that there's some ambiguity, right? Like I ran this /review command, and it's expecting, hey, I have commits that are ahead of my base ref, right? Or I have unstaged or uncommitted changes. In this case, I'm just on main, so it's asking me what I want to do. Like, hey, do you want to review the whole repo, specific branch, just the latest commit merge? I'm going to say, let's just go ahead and do the latest commit and merge.
Oh, then you get a free text.
Then it says branch name or commit range if applicable. I'm going to just say, you figure it out.
Oh, it wants you.
Best judgment.
It wants you to.
I don't have the
specify.
commit number off the top of my head, unfortunately.
It gave
but
you something there. It gave you like a. I thought I saw a hash.
Maybe it did. Maybe it did. I just missed it.
Yeah, we're moving.
We're
too
flowing
fast.
here.
I don't have time to read everything the agent says. They write walls of text, man.
Yeah.
I'm too busy. I'm
Well,
building things.
Yeah, it's interesting that you say that because that's actually something that we've experimented with in the GitHub app and probably we will bring into the CLI is sort of different, being able to configure different levels of brevity. Some people really love being able to see in complete detail the entire log. Some people just want the final output.
Yeah, say it in as few words as possible. Like, I don't know if y'all notice, like if you have people who send you or you read things that AIs have generated, they're like this long, man. Like people send me an email that looks like they spent an hour on it. That was written by an agent. You're wasting my time. Boil it down to one sentence.
This is the beauty though of these coding agents, the CLI, is there's lots of ways to configure them. Skills, hooks, custom instructions. So I'm actually just going to go ahead and like implement Burke's suggestion here. I'll hold down the space bar. I'd like for you to add to my custom instructions that I want you to be as brief and concise and to the point as possible, unless I ask otherwise. Like one sentence. Make it easy for me to read and scan. I'm just going to hit enter here. This is going to update my Copilot instructions file and generate a new instruction where now the agent is going to be a little bit more tailored to me and how I want to work inside of this repo. I'm doing this in the repo because I own this, but if I was working in a team, I would put this in my .copilot folder where I could have personal instructions that are specific to how I want to work with the agent.
Now, I notice you keep using voice mode.
Yeah.
Is that a plugin? Is that something like, how does that work?
Yeah, absolutely. So you can toggle voice mode on and off here with the /voice command. And if you show models, we have an English and a Spanish 𝗦𝗲𝘀𝘀𝗀𝗶cie model. There are other models that are available to download as well.
These are local models.
These are local models. I believe they're from NVIDIA, but
Yeah,
you have to,
𝗦𝗲𝘀𝘀𝗀𝗀's
you have to check me on that. And the nice thing about these models is that they stream. So the first time you set this up, you have a download. Let me see if I can look back. So it's a big model. It's 700 megs. But the nice thing about that, all of it running locally, and then I don't have to hit the cloud or hit an inference provider for this.
Yeah, that's super nice. So a question, how many of y'all are using voice mode and talking to agents? Is anybody okay, how people type to your agent? So most people, why? Are y'all uncomfortable talking to, just like speaking out loud? Because then it sounds like you're just talking to yourself. Is that what it is? Because that's how I feel. I feel uncomfortable when I do it. Different part of your brain. So like when you're typing, you're thinking, and when you're speaking, I don't know about y'all, but when I speak, I don't think, obviously.
Well, I would say for me, Scott Hanselman is the one who turned me on to voice mode.
He does everything in voice mode.
He does everything in voice mode. And when we were doing some early dog fooding of the GitHub app, and we had these weekly 1-hour Scott dog fooding sessions where we would watch him use the app, and he was using Handy at the time. And at first when I saw it, I didn't really get it. And I tried it once or twice, and it didn't really stick. But eventually I realized I'm kind of a person who likes to pace around my office while I think, if that makes sense. So I have like a little USB remote that's hooked up to that shortcut, and I pace around my office with my headphones on, and I ramble at my agent.
Like dictation.
Like dictation. Like I'm walking around in circles, thinking, staring at the sky. It works for me.
It's 1965. We're all dictating to recorders again.
Exactly.
All right.
Exactly.
Well, Evan, thank you. Do you have any other sessions here? What should people do next?
I do. I have a 4 p.m. session with Mario about the GitHub app this afternoon. Already did a session with Cassidy this morning that was recorded about the Copilot CLI, going in depth on the features. The session with Mario on the GitHub app is at 4 p.m. today. Encourage you all to attend that. If you want to learn more about how the team and I use the GitHub app and use agent workflows to guard our focus and focus on output rather than activity with coding agents.
Awesome. And for those y'all who, listen y'all, and for those online, if you're skeptical about these CLIs and these TUIs, then I definitely want you, more than anyone else, to go install the Copilot CLI and just try it. Just try it, okay? That's my challenge to you, because I understand the skepticism. I was too. Then once you do it, you're like, wow, that feels amazing. So just give it a try, see what you think. All you got to do is Google the Copilot CLI. You'll find it. You can't miss it. Evan, thanks for being here.
Thanks so much, Berk.
We'll be right back. Thanks, y'all. See you in a minute. So I'm using Rust, and so here, let me walk you through what I did. So first of all, I took a photo of the challenge with my phone.
I did the same and airdropped it to my machine.
Same thing. And then, so first I had to ask, is my machine configured to run Rust? Can I build a website with Rust? Because I don't know. So it's like, Rust isn't installed in your machine, here's how you can build. I was like, cool. So yes, install what I need, and then I'm gonna get a prompt ready for you. And then this is my prompt. We're doing the Vibe coding contest. I'm gonna give you the rules. Yep. And then I said, boost the prompt. It's basically like add more fidelity to the instructions that they provided us. Yep. And then create a detailed plan. So then I went into plan mode. Yep. And then I said it would be better if we could deploy it, but we have to get it running locally. That's P0. If you have any questions, let me know. So then it goes through, and I don't know if it's going to show the questions here, but one of the first things it said to me was, it goes, hey, you don't need Rust to do this. You just need HTML and JavaScript. That was like the first thing the agent said. It was like, do you still want to use Rust? So then I switched to my custom agent, which is the beast mode rebooted. Yep. So my custom agent here does a couple of things that are important. So first of all, it forces the thing to use context 7. It forces it to run things in sub-agents. I know I'm not supposed to use sub-agents. I don't care. I'm doing it anyway. I told you I wasn't going to listen. And then it lays out some mandatory coding principles. Now, then the next thing that it does is I switched into autopilot, which I think is experimental in the CLI, but it's essentially the Copilot CLI's version of a Ralph loop. Okay. And then it just keeps going, it keeps going, it keeps going. It's trying to test, it's opening the local host, taking screenshots, and then we get down here to the bottom and it's like, okay, cool, I'm done. And I was like, well, how do I run it? And so that took me a minute to figure out how to run it, but it's up.
Dude.
So there's a couple things. So first of all, I used the front-end design skill from skills.sh, which I've installed. Like, it's just there. And Theo told me that Opus 4.6 with the front-end design skill is like, that's really the most goated way to do design. So that's what I did. And then the agent browser skill is what it used for to test. To make sure that it actually ran. Because one of the problems with agents is that they can't close the loop. You're the one who pointed this out to me. And so what they do is they're like, cool, I did it. And then you go and you're like, you didn't do it.
And you're like,
it doesn't work at all. So it has to be able to close the loop. So the agent browser skill enables it to use a browser and do that. I don't know if this actually works though. Hold on. Can we give people kudos? Let's give John some kudos. Hey!
Ooh, look at that animation.
Look at that animation. Wait, does it persist if I reload the page? It does!
Wow, that's
Am
really
I done?
impressive.
Did I win?
Hello, my friends. Welcome back. We're here at Microsoft Build, and I'm super excited to be here with Julia. How you doing, my friend?
I'm doing fantastic. Thank you.
The thing I love about Build is we get to talk about the cool stuff behind the scenes, and we get to ask all sorts of questions. We have a live audience here as well, so they might ask some questions. Why don't you tell us who you are and what you do?
Cool. My name is Julia. I am a product manager on the VS Code team. I've joined the team last year in August, and yeah, it's been a fun ride.
But the thing is that you just don't work on VS Code. Like, let me paint the stage. We're in agentic coding era. Like, for me, it started last December. And we kind of go and we pick the model, and we just happily just go along and pick a model. And it seems super easy, but that's what you work on.
Yes.
It's not as easy as it sounds, right?
Yes.
Tell
So
us about
I thought the same thing.
Okay.
Funny that you say this. I'm like, I'm in VS Code, I'm using the chat extension, and from time to time, like a new model shows up, and I'm like, oh, great, I'm just gonna use the new one. Now, since I joined the VS Code team, I'm in charge of, or I'm helping the team, not in charge of, but I'm helping the team. It's very collaborative. What all goes into releasing these new models in our VS Code extension. And it is a ride, I can tell you that much. It's not as easy as, we get a new model endpoint and boom, here it is, and it just works. There are so many things and pieces that go into this, from us working very closely with the model providers and like getting their insights and what the new model is all about. So yeah, there are a lot of things that go above and beyond here.
So I'm just picking the thing, and I'm like, these things are all compatible or the same. Can you give us a sense for how not the same? These are all very special flowers, whether they're from a certain company or from a certain type. Tell us about that.
Yeah, so I think the biggest aha moment for me was, even within the same model family, let's pick the GPT ones.
Okay.
GPT 5.4 to 5.5, even within this model family, it kind of had its own new personality, and we had to adjust our coding harness to it. And that's why we work very closely with them, because for us, the models are also a black box. So we are getting their insights, like what has their research team worked on and making the new model endpoint better. So it truly is like every new time we are getting a new model, it has its own personality, even more across different model providers like Anthropic and OpenAI. These even differ even more, but even within the same model family or like model provider section, it's already very, very different.
So we talk about models, even from 5.4 to 5, you talk about personality or characteristics trait, and you talked about the harness a little bit too. Do you have to make changes to the harness for every model? And if people don't know what a harness is, can you help them understand what a harness is and how new models make it so you have to change some stuff?
Totally, yeah. So I brought a little bit of
Let's go to the screen here.
Flowchart diagram.
Okay.
Just to give a very high level of, hey, these are all of the steps that we have to think about. As I mentioned, we work very closely with the model providers. So I thought it was very processy. Oh, yes, of course, we learn about this new process. It's very casual. The model providers reach out to us. They're like, hey, our research team told us we have something that is working. And then our entire team, from the Copilot API team that gets the new model onboarded to also us on client side, like VS Code, we all go in and we start working. And in particular, we work on optimizing the harness. So what is this harness? The harness itself is the system, the environment your AI or your LLM is running. Essentially, the LLM only provides or gives back tokens, but how do we make changes? How do we edit files? How do we run in terminal? So this is what we consider our harness. And these are all of the changes we have to make sure it works once a new model comes up. And there are 4 very important things we always look at whenever we have a new harness. It's our system prompt. So for every model, for every different model, across even different model providers, we have our own system prompt. We have different built-in tools that these models can call. And even across different model providers, they tend to call different tools as well. So we have to make sure the right tool sets are being called. And then also context management. Different models have different or work with different model contexts. And then also the agent loop and how do we call it? How do we load tools? So we just have to make sure it works end to end.
So hold up. So you effectively, every time you get a new model, every model gets its own special flower kind of situation in the harness so that for us, as we're using this, we really can't tell.
Yes, correct. Well, actually, so let me switch over to my stable.
Oh, can you hit Control Plus a couple times?
Yes, of course. There you
go.
All right, so this is a fun little project. It's called DJ Julia.
Control Plus one more time, because I'm old.
There you go.
There you go.
It's just like a fun little project that I have. So right before this session, I created this prompt, which is, hey, for my DJ app, I want you to create a new music pattern for me. And just to kind of show you, first of all, everyone can go in and explore what the harness does whenever we make these calls to the LLM. So you see a bunch of styling. It does a bunch of different things, right? It's searched. So whenever you switch to our chat debug logs, you can really see all of the different things that is happening behind the scene. So
hold on, you went really fast. Let's pause for a second. So there is a chat debug log where you can see effectively every step the harness has taken.
Exactly. Every step, every tool call, what is the system prompt that is being applied. So here, for example, let me close this real quick. You can see the request message is being separated between the system prompt. And you will notice, so this one is with the GPT 5.5 model. If you would do the exact same prompt with, let's say, Opus 4.6, it will have a different system message as well. That's how we optimize and we make sure every new model gets the latest and best together with the model providers that we work on, because they clearly know the model so much better. And it also helps us to really optimize and make sure it works truly end to end as well. And then also, if you're interested in seeing all of the different tools that are being called, as an example, the GPT model family always uses apply patch versus the Anthropic models, they use insert file. So just some nuances how different all of these models truly are.
So you talk about like how different they are. Is there a way you could show us like how they are different?
Sure. Let's try this here. Okay. So use this. Let's go back. And for everyone to see, I use this using the GPT 5.5 one. So let's just do this with the Opus 4.7 one. I'm doing the exact same prompt. So first of all, also another challenge we have in the AI space, even using the exact same model, it is non-deterministic. So every time you run this, even within the same model family, you will always get a different input or output. But just to show you how much they differ, even across within the same harness, and just having the different model here.
Yeah, and because I mean this thing is sampling, according to distribution of the model's output. I like to say stochastic process as much as I can. It's like a $5 word, makes you sound really smart. I don't know what it means all the way, but that's what they told me. But effectively, this is all probabilistic, and so it's going to be different every time, even within the same model.
Exactly.
Okay.
Yeah.
So what do you got?
So all right, if you remember what we had before, our system prompt. Let's go here. There you go. So this was the system prompt we had previously. Just gonna close this. It does like a bunch of pre-classification checks and stuff like that. So now if we go to the latest one that we just did with the Claude one, you can see the instruction files are different. With the GPT 5.5, we had something to make sure it inserts before, because the GPT 5.5 ones, they are more prone to immediately go and run in terminal. But we wanted to first explore a little bit and then go and run it, because we have seen so much more success with these kind of system prompts rather than using the ones that we previously had with 5.4. And all of this was worked together with the OpenAI folks.
And this is really impressive because, like, betwixt us friends, I built my own harness in Rust, and I started changing models assuming that it was going to work, and things just stopped working. So you effectively have to, when a model comes out, it's like, all right, gang, let's get together. Let's figure out what the right prompt is.
Yes.
Let's figure out how they do tool calls, et cetera. You have to do all of that work.
Exactly, yeah.
Okay.
I mean, I love that you're building your own harness, but one of the benefits for using our built-in one, and there's no harm in building your own, and of course making your own changes, is we do work very closely with them, and we are truly optimizing for all of the new checkpoints, and we are optimizing in a way that it will hopefully work for most folks out of the box, and you don't have to worry about it, because we know how much work that actually goes into always updating and making these changes, and that's one of the benefits for using GitHub Copilot and VS Code
100%.
as well.
My harness is nowhere near as skillful as theirs, and it's literally for helping me write stuff. And so notice that even for a separate task, does your harness have to be different, or is this all optimized for writing code?
That's optimized for writing code. That's why you see in the instruction file, usually the very first one is, hey, you're an expert AI programming assistant. So we are putting the model in context of where it is. It's in a coding environment. It has to make sure it is not just like giving you text. It is going in, it is using our built-in tools like run in terminal, all of these things to make sure it works in the environment we are kind of grounding it into.
So I'm assuming you're not like, oh, we got a new model, everybody. Let's just use the last one and change a couple of words, see what it does. I'm sure there's like a better process to do this kind of testing. Can you tell us about that?
So to be very honest, a lot of the times whenever we get a new checkpoint, the very first thing, and this is something we get from the model providers, they tell us, just use the system prompts from the prior model, and let's just see how it goes. And we're like, okay, I guess, because they're also, so the reason why they want us to do that is they want us to see how good it already is without doing all of the optimizations.
Extra work,
yeah. And how do we measure this?
Yes.
So we measure this by running a bunch of offline eval benchmarks. We do this by internal dog fooding. So these are two in parallel things that are going on. And once we have these benchmarks run, we share the results with the model provider. And then based on that, they're like, oh, okay, I see. It's already maybe better, but let's start tweaking and let's start going in. How about this? So then we sometimes have had a model where we basically just removed everything and we're like, okay, we have to start from scratch here. And then we optimize it to make sure whenever the model launch day is, it truly is the perfect model to hit the crowd.
So, but there's got to be, like, for example, I'm a traditional dev. I did some machine learning. We had things called evaluations. We do things as devs as unit tests. Do you have something like that you systematically run through to improve the prompt or see, like, hey, it's this good, but now it's this good? What does that look like in your process?
So our process here, and this probably is going to touch a little bit of evals. So yes, we have offline evals, especially we run these before the launch. After launch, we also still optimize the harness, which is very important. It's never a ship and let's go.
Course.
It's always like we go in and we iterate even after. So what are the benchmarks or how do we evaluate it? There are a bunch of public benchmark out there. 𝗬bench, one of the very known ones. And we still run these, even though there are a lot of controversy around these public benchmarks, one of them being, and the model providers have told us directly as well, the models are so smart now that you're always kind of going to get this. So use this as a regression test rather than really evaluating the quality of it. So we still run these, we share it, we see if the model has regressed. We use it for optimization of our harnesses as well. But then the more important one is we have our own internal benchmark, which is called VSCbench. It currently has 100 and plus tasks or instances that we run every time. So before launch, we run across different reasoning efforts. We make some changes to the system prompt as an example.
Right.
We see how it changes, and we look at these, what we call model report cards, to see how it's performing against it.
So you're not just like YOLOing a model out.
No.
You have a full benchmark of a bunch of stuff that you're testing. Can you show us a little bit the card to help us out? Show us that.
Awesome. So I did this morning.
Can you control plus a couple of times?
Sorry, yes.
You're good, thank you.
There you go. So I ran this morning, and basically how it works is we have a VS Code Insiders instance in an ACA. So whenever we run our offline evals, we spin one up. It's always using the latest. So I ran it this morning, so it truly has the latest Insider version in it. And how I did this, I ran it against GPT 5.4 2 times and GPT 5.5. Typically, we try to run it 5 times because of the non-deterministic problem that we have with AI. So then a next step, this is where it gets really exciting, is the performance metrics. We look at the resolution rate. So resolution rate is, was this task successful or not? And we evaluate this by certain assertions we have, and we think of it like a checklist, and it goes through and says, for this test case, was it resolved? Did it hit all of the check marks? Yes, and then it's resolved, and it goes in and shows 153 out of the 248 test cases were resolved. And this is how we can compare across the different model families.
This is pretty amazing. So what should developers take away from this? We got about 45 seconds.
First of all, always keep trying new models. Give us feedback if there's anything that doesn't work as expected. We are continuously operating and doing this. And also, I've done the same. I gave a model a one-try kind of thing. But because we are putting so much effort in these models, just make sure to maybe sometimes come back and give it another try. And also then evals, offline evals are a huge topic, and anybody building their own coding harness, it has been one of the tools that we as Microsoft have been super successful, and the model providers are loving. So definitely a space to dig more into.
Awesome. Well, thank you so much for being with us, and thank you so much for watching. We'll see you after this.
Thank you.
I'm so excited you're here because, as many of us, we've been experimenting using GitHub Copilot and assigning tasks, switching, using that model selector. And a lot of times, I don't really know what model to add. And now, thanks to you and the work in your team, we have the auto selector mode.
The model landscape is changing so quickly. And that's great for AI advancements and our industry. But what it does add is that extra layer of complexity. So questions around, what model do you use? What scenarios do you use them for? And how do you actually scale that when there might be a new model version or a new model that comes out the very next day? We wanted to be able to abstract that complexity away from you and actually automatically give you the best available model for your task in real time so that developers can focus on what they want to do. And so we do that through Copilot Auto Model Selection, or Auto for short. The best part about Auto is that it's extremely simple. There's no configuration, no policy toggles that you have to do. All you have to do is go into your favorite IDE, the GitHub Copilot CLI or Copilot Cloud Agent, and go into your model picker.
Hello, my friends. We are back, and I love AI. And at Build, Microsoft Build this year, there was a ton of models released. I think there were 7 MAI models released. But one of the ones that was super interesting to me, because I'm a dev, is MAI Code Flash. And I have some of the researchers here with us. We're going to ask the hard-hitting questions, and I'm going to try not to sound dumb because these are the smart dudes. Why don't you tell us who you are and what you do? We'll start with you.
Hi, everyone. I'm Yang. I'm the research lead of the training part of this model.
I'm Hong Chen. I lead the development of my coder, build the model.
So this particular model was specifically built with GitHub Copilot in mind. Is that right? So Peng, why don't we start with you? What does that actually mean?
Yeah, to me, the purpose-built model means we didn't take a general purpose model and adapted it for code at the end, but actually we built from the very beginning for GitHub Copilot scenario, and we optimize it for around GitHub Copilot experience from very beginning.
So for those that are like thinking like, okay, MAI Code Flash was optimized with VS Code, with Copilot in mind, what does that mean for people?
For people means it's not just generate code snippets. It will understand the repository context, use tools, understand the user's intent, and make targeted edits and respond quickly. Especially for GitHub Copilot users, we will optimize for the real user workflow.
I see. So why don't you tell us more about what that looks like in practice when you optimize for VS Code?
Yes, so I think it means it's not just good at some benchmarks, it's definitely good at many benchmarks, but in the real code agent, it also means like it interacts with you in a proper way. It asks your questions without long thinking for some simple questions. It do the unit test at the correct time, at the right time. It do the proper testing. So it basically optimizes for the best user experience in VS Code.
So tell me more about that, because like I was trained in machine learning, and effectively what I understand models to be is it's this huge structure. You push a lot of data through it, some linear algebra and calculus to optimize it. Tell me about the data that you're specifically pushing through it to make this model super good for VS Code users.
Yeah, that's a very good question. So that's why reinforcement learning plays a very important role here. So which means in this training, we let the model interact with the real product harness, with real VS Code, with the same tool sets that developers use every day, with the same prompts you use every day. And it can interact with the repo, with the environment, like your daily suite tasks. And we can grade and reward model with a lot of, like, is the task fulfilled for you? And does it like have very proper product behavior? And also many things that you think the model should do the best for your daily suite task. And it's all be done by very good reinforcement learning with a real product harness.
I see. So there's a base model, and then you're doing reinforcement learning on top of it to adapt the behavior. Is that right? Tell us more about that.
Actually, it's multiple stages. Reinforcement learning is the last stage to make the model perfectly aligned with user experience in GitHub Copilot.
So tell me more. So you're actually, when you're training the model, you're training it with the actual VS Code stuff. Is that right? Tell me about the stages.
When we train the model, we have multiple stages. We started with supervised fine-tuning to make the model follow user instruction and response with aligned format. And then we gradually train the model with a lot of diverse data in a criminal way, from simple coding task to complex coding task, stage by stage. And the final stage is that we use reinforcement learning to make the model to learn in the real environment as a product. So, and evaluate in the real scenario, real environment as a close to product, so that we make the training, evaluation, and the production in the same workflow. So that's the difference from our model. That's the difference of our model from a general purpose model.
And this is so cool, because I want to restate this, because as I'm hearing this, it's kind of super cool. You basically have a base model, and you do supervised fine-tuning first with simple tasks.
Yes.
Then with more complex. It's almost like you're taking it to school on how to be a good programmer.
Yes.
Simple tasks, more complex tasks, and then you test benchmarks over the top of that. Is that right?
Yes. And this benchmark is not general benchmark. So this benchmark is customized to use the same environment as our product, use the same harness.
So it's a purpose-built model for people that use this harness.
Yes.
That's really cool. So this is cool. Tell me about the model size, because one of the things that I tell people is, hey, if you're doing a generic task and you're not sure, you got to use a pretty big model and then learn and then make a fine-tuned smaller model. Tell me about the model size here and why that particularly matters.
Yeah, the MAI code 𝗏 is a 5B model, active parameter model, but actually a MOE model. So the total capacity is about 137 billion parameters, so which is fairly large. I think model size plays a very important role here. It's like it kind of have a trade-off between the model intelligence, the speed, and the cost. That's the three things that we care about. And with this large MOE model, but with small active parameters, it actually achieves a balance point or sweet point for your daily suite tasks. You don't need to waste a lot of tokens, but you still have very powerful models for your daily work.
So tell me more about that, because you said a 5 billion parameter model, but you're using a mixture of experts. So tell me how that works. So for people that haven't heard that, what does that look like?
So basically, imagine it's a neural model and you have a lot of parameters, but in each token, in each inference, we only need to activate a part of them. And that part of them will serve a task. The rest of them can be activated for other tasks, for other tokens. So which means in each inference, only part of the network is activated, and this saves a lot of cost.
Yeah, so the total model is only 5 billion parameters, or?
No, total model is 137 parameters.
But only active at a single time is the 5 billion because of the mixture of experts.
Yes.
And this is the cool part that I love about this. Machine learning has gotten so good that a mixture of experts effectively shuts off an entire part of the model using nice vector calculus, and it pushes the exact query through one of the experts, so that you're actually getting super fast inference speed. So effective model size is 5 billion parameters.
Yeah, not just one expert, it's like mix of many experts. Yeah.
That's amazing. So what does that mean for speed and accuracy?
So if you look at our blog, our model, you can see the latency of model is super good comparing with the same quality and intelligence. And also, as Ipeng mentioned, we also optimize model for token efficiency. So if you combine model efficiency and token efficiency, you will find it's just a beast at its size.
It's just because it's like a big model with little models that together make it a little bit faster.
Yes.
So what has been the most exciting part for you and challenging parts of building this model?
I think actually there's a lot of challenge, as I said. From beginning, the model just put in next token, so it cannot follow user instruction or use tools. So we need to do something called a code start to make the model can follow user instruction and do some simple reasoning tasks. So basically, it can just like children. We start from a very young baby and make it gradually go up to a postdoctor.
Yes.
So that's a good. The first step is the kindergarten, right? That's code start, and after that we can keep the model, make the model keep climbing and to the higher level.
Yeah. So a lot of folks. When I look, and this, I fall into this trap because maybe, I don't know, we like biggie sizing things. Sometimes we fall into this trap of thinking that a bigger model is going to be better at specific tasks. And that's not always the case. Sometimes a smaller model can be even better. Why is that the case for MAI Flash?
So I think model size matters a lot for intelligence, but not all of it. We take good care of the training. We use the same harness. Very proper design data for this model to make sure the model can always climb on its rewards in training. So I think the outcome is very good. It's not just limited to its size. It's a very powerful model. Yeah.
Okay, so I think you've brought something to show us. Can you show us what we got? So we're going to go to the screen here, and you brought a little bit of something to show us in action. Is that right?
Yes. So what I'm showing is a demo we just made. This is using our model in VS Code, developing a front-end web app. You can see the model is very fast. You give it a prompt, it do a lot of things, like the token on the fly is super quick, and use the custom model is trained with VS Code 2 and use the native VS Code very efficiently. And in the end, you can see it developed a very nice-looking app in a very short time. And I think here's another demo. It's a bit different. The model is prompted to build I would say, a retro-style game. And you can see the UI looks good. We do put a lot of efforts on improving the model's front-end ability. And with the native harness in training, you see it pretty efficiently.
Yeah, and this is pretty cool because now this particular model is available in VS Code for people to use. Is that right?
We are rolling out the model gradually, and you can use if you got the model, you will see you on Model Picker.
So, what has been the funnest part about building this model? Because, like, in this case, you're building a frontier model, but for a very specific use case. What are some learnings that you've had along the way?
Learning, I think users' real workflow is important for us to optimize the model for users' purpose.
Yeah.
Instead of general benchmark. So without using the Copilot deterministic grounded task, we cannot make the model work as perfect as today in Copilot.
And can you tell us a little bit about how you test these models so folks get a sense for, because you're not just like doing weights, but you're testing these models as they go. Tell us about the testing process.
So definitely, we have very good benchmark results. If you look at the blog, across many benchmarks, I think it's a frontier model at its size. As Colin said, we also care a lot about your user experience. So that's why we do a lot of A/B testing online to make sure the model can fulfill your test. Your engagement with the model is correct. You don't cancel too much for the model.
So if you've used this model, tell us what the experience has been like using this model. You said it's a little snappier, it's a little faster. Tell us about the experience.
To me, I think for most of the tasks, it's comparable to today's frontier big models. But just for some challenging tasks, we must recognize the scaling law. Right? We cannot disable the scaling law. Small model still has some limit for challenge, but for most of the daily work, I think this work works good for me.
So generally when we go from a bigger model to a smaller model, it gets very focused on the particular task that you fine-tuned it for. What are some things that like people should not expect it to be? You know what I'm saying? Because I don't want people to use a model and be like, wow, it's not writing poems for me or something. Tell us about what are some things that are super good at, and what are some things that maybe you should use other models for?
So I would say for most of our daily suite tasks, backend, front end, different programming language is a very good model. But the writing a poem, do a lot of like creative writing things. We are not optimized for that, but I can still do something. But maybe you should use other models. Yeah.
Cool. So I hear you have one more demo. Can you show us that one? And this one, does this one have audio?
This one has audio.
Yes.
Okay, so are we equipped for audio, Tom, on this one? We are ready for it. Okay, they're ready for it. By the way, Tom's awesome.
So this is for fun project, so we can project.
Can you maximize it?
I can start coding agents, give them tasks.
That sounds cool. Can you run the web app locally so we can start testing?
I got it. Let me work on that. I need your approval to start the Vite development server.
Sure, I approve.
The development server started on localhost app.
Thanks. Can you now change the background color of the web app to a gradient of blue and green?
I got it. Let me work on that. The agent updated the project.
Thanks. Now can you check what kind of unit tests we have and see if there is any missing and create them?
I got it. Let me work on that. The test suite is ready to run. I need your approval to execute the NPM.
Sure, I approve.
The agent added unit tests for the profile header.
What's going on with the agents right now?
One moment, checking. All three agents are actively checking the current app structure. One is planning to refactor components into a
So tell us what we just looked at.
So this model is actually our weekend project. We combined our latest state-of-the-art MAI transcribe model, MAI voice model, and MAI code flash model for this fun project.
And that's kind of cool because now that you have specific purpose-built models, you can start to put them together, do some really cool things. Tell us about how you came up with this.
I think it's very natural when MAI comes all these 7 models together. So it's kind of natural to think how we can combine them and how we can imagine the Sui developers in the future. So that's a very natural project. Yeah.
So what should developers take away from all of this? We'll start with you and then we'll come to you.
Take away, I think imagination is important. Right? We can imagine in the coming few months we have even better things come out. Yeah.
Fantastic. What about you?
I think my takeaway is we are seriously training the best model for our product, VS Code, and other products. And this is just the beginning of our journey. Please stay tuned and looking forward to what will happen next.
That's amazing. And so as developers try this out, make sure you give us feedback, because I'm sure you want feedback on how the model's working.
Yes. Yeah, feedbacks are very welcome.
We love feedback.
And you're going to continue to improve this model and do work, is that right? Tell me about the future of this.
So definitely, as Hun mentioned, we need feedback so we can improve the model. And this is a mini-sized model. Just stay tuned for some more powerful beasts.
Awesome. Well, thank you so much for spending some time with us. This has been amazing. I'm a nerd. I love this stuff. So thank you so much. And we'll be back right after this. We'll see you.
Thank you.
let's talk a little bit about the project to port the TypeScript compiler to Go. Can you talk a little bit about the motivations, kind of the trade-offs, the challenges of making that transition?
Yeah. TypeScript from day one was self-hosted, written in itself. And that meant that TypeScript, the compiler, the tool set, everything runs simply as a JavaScript app. Now that has a bunch of advantages. Like heck, you can run a compiler in a browser, and then so you can have an IDE in the browser, with the full compiler and language service, and everything just works. But it comes with some drawbacks too. Precisely because of this massive adoption and then like the ever-growing size of projects that our users build, scalability has just become the #1 issue. And then there's some inherent limitations of JavaScript itself. It's the language is by design single-threaded and does not give you access to shared memory concurrency. So you're leaving like 90-some% of the compute power on the table, right? And then JavaScript itself is it's an expensive language, to execute. It has a very permissive object model. You can just like walk up to an object and start slapping properties on it. And that means it's hard to optimize because this ultimately, when it runs, ends up being some hash table lookup, and there's some caching and there's some da-da-da-da-da and whatever, but it's not like native code. So we knew we were leaving money on the table, left and right. And as much as it pained us to give up on self-hosting, I can't say enough good things about our team and about how smart these people are and how well they understand how JavaScript works and how surprising it is what you need to do to optimize. Like sometimes you have to do exactly the opposite of what you think you have to do in order to make this code go a little bit faster because of the way V8 is architected. And I mean, we had all of the tricks. We had found out and we had applied and whatever, and it was still just, we're never going to get any faster.
Hello, my friends. Welcome back to Microsoft Build. We are here on the live stage, and I'm super excited to be here with Daniel. How you doing, bud?
Doing great. How about yourself?
Fantastic. So why don't you tell us who you are and what you do, and this is going to be a fun one. Tell us about it.
Oh, it's going to be great. So my name is Daniel Rosenwasser. I'm the product manager on the TypeScript team. I've been there for a long time. I started out as a developer, moved into the PM space because I just kept talking, and they were like, all right, let's move them over here.
Nice.
Yeah. But so I've been working on TypeScript. So that is the language, the compiler, the editor experience that you know and love in VS and VS Code. And also, if you're just doing JavaScript in these editors, like we're supporting all of that stuff. It's all powered by the same guts that we've been working on for a long time now.
So I remember talking to Anders about, I don't know, it was a year ago or so, about a major change. But before we get to that, I realized, why don't you tell people what TypeScript is, the blurb? Sure. It's super cool. I use it all the time.
Yeah. So basically, many, many years ago, we found that there was like just this continuous problem for a lot of developers building out big JavaScript apps, right? All of us need to have websites. All of us need to have apps that are cross-platform, that are accessible in the browser sometimes. And so as we sort of needed to do scalability and like actually create more complex apps, we found that there were a lot of other things that we were sort of missing from our other languages. Like in C#, like that certain things are just plain not going to work.
Yeah.
Not just from like when you compile it, but like as you're typing it in the editor, you're getting a little red squiggle, right? The same way that in Word, you get something that tells you, hey, you might have made a mistake here, a typo. And so we knew that there was a great opportunity for great, solid safety and developer tooling that we could give people. And also, at the time, we were able to bring people modern JavaScript constructs that were still not really available in every browser and runtime. And so TypeScript was a way to take JavaScript and add syntax for types and add a type checker and a compiler so that you could bring all the modern features that you know and love today. And the cool part is, when I first started on that effort, right? I mean, I wasn't there from the very beginning, but I was there from early days. Yeah. And it was like, this is ambitious, right? This is Microsoft. Yeah. We're trying to do an open source project that is in the JS space, the JavaScript space. And a lot of people were like, I don't know. Even before I joined Microsoft, I was like very skeptical about that effort. And then I joined, and then I found out that really the team behind all of it is really passionate and had a very good sensibility of like working with the community and really trying to have a good sense of developer tooling. And so
it's been nice.
Yeah, it has been nice. So nowadays, I mean, I don't know if you caught this on the GitHub Octoverse this past year, but TypeScript actually became the #1 programming language on GitHub. Yeah. And so, if you like, beyond JavaScript, right? And so that is kind of nuts. If you had asked me that back then, I would have just laughed you out of the room completely. But now the thing is that's interesting is that TypeScript is now the #1 way for people to build JavaScript apps, period, right? Like, we don't really think of these things as so distinct anymore. It's not like TypeScript versus JavaScript. It's I'm doing JavaScript development and I'm using TypeScript, and that's just kind of the core experience.
Yeah.
I don't know. I mean,
I think it's awesome. Like, I use it all the time. In particularly large JavaScript projects, having type safety at the compiler level is super nice. Transpilation layer.
Yeah.
So about a year ago, there was a major shift.
Yes.
Because TypeScript was built on TypeScript, kind of TypeScript on TypeScript, but there was a major shift that happened. Tell us about that.
Right, so TypeScript has been built in TypeScript for over 10 years now, right? It's kind of this food process.
It's 10 years already?
Oh, over that, yeah. And it's like, people call it dog fooding, right? Like, you eat your own dog food so you know how good or bad your dog food tastes, or bootstrapping. Basically, by us doing that, that gave us a really solid sense of like what the experience is day to day. But the problem with TypeScript being built in TypeScript is it ultimately compiles down to JavaScript.
Yeah.
JavaScript has had a miraculous amount of development on all the engines, like in V8 and SpiderMonkey and all that. People have made it really fast for the dynamic, interpreted language that people kind of knew from like 1995.
Right.
But ultimately there's an overhead, right? There's always going to be a little bit more that your engine needs to do. And so there was this sort of gap between what JavaScript is able to do and what you're able to do natively on your CPU, right? And JavaScript kind of fundamentally is single-threaded, right?
Yeah.
There's ways to do multi-threaded JavaScript, but then these threads can't really share the same memory without handing it off fully to each other, right?
Yeah.
And we looked into all sorts of solutions to try to make things faster, but we, as TypeScript's kind of been promising on its, delivering on its promise to do complex JavaScript apps, that means that there's a scalability gap, not just in terms of scaling on your team, but scaling on a big code base. And so people complain, like, my build times are slow. I'm waiting for my editor to like actually load up all the code I've got on disk. And so, all right, let's cut to the chase now.
Yeah.
We actually chose to do a rewrite in the last year and a half or so, taking the existing TypeScript code base and porting it over to Go. And in that port, what we found is a typical sort of speed up that you'll find on many code bases is around 10x, right? Which is pretty mind-blowing.
Yeah.
And so part of that speed up comes from that native speed, and part of it comes from shared memory parallelism. So we're able to actually go faster, not just on one core, but across all the cores that you've got. And I've got a little bit of a demo if we want to dive into that.
Yeah, let's do it.
Too.
So
yeah.
just to recap, effectively, you didn't TypeScript isn't Go. It's Go is being used to do the transpilation, to do the type checking, to do all the other stuff.
Right, in a sense, like basically all of the code that we had in the TypeScript code base, we took like, we've got different components. We've got a parser, we've got a checker, we've got like an emitter to like do your code gen. And each of those components was ported over to Go code. But at the end of the day, you're still using this to compile TypeScript code, right? It's still reading JavaScript, it's reading TypeScript, and it's emitting JavaScript, and it's giving you the same exact errors that you've had in the past.
And before we go to demo, because I remember talking to Anders about this. It wasn't like you just like wrote it in Go and wrote new unit tests. You basically took every part piece by piece.
Yes.
And tell us about that process, because it was not like it was a very methodical approach.
Oh, totally. Yeah. So this was also back when agents were a little bit more flaky in the reliability and stuff like that. So a lot of people say like, why didn't you could you have just viported it over, right? And so definitely at the time, no. But the cool thing that we did was we used agents to actually write infrastructure to automatically port parts of our code base, right? So like the initial stuff was methodically going through the scanner and the parser. So these two artisanally crafted.
Artisanal code, yeah.
And so once we did that, we kind of had a sense of the data structures and how all of the code would look and how we wanted the code to look. And that allowed us to say like, okay, we have a sense of what we want. Can we partially automate this? So we actually had a script that would take a TypeScript file, right? All of our files are kind of uniformly written in a specific style. And we would say like, oh, when you're going through the parser, rewrite parts of the parser in so-and-so way. And that way, whenever you're missing something, right? Like you have portions of your component, you say, oh, well, I'm missing that functionality. That's literally a function that you're copying and pasting between the two code bases. And then you evaluate, is this new function how I want it, like, is it acting the way I want it to act? Sometimes you'll get a compiler error, and it's intentional because it makes you sort of think about like, how should this act? So you're just sort of like ripping pieces of auto-generated code into the new code base. But the cool part about that is that it's all very deterministic, right? So if something is not right, you can always say, well, this script needs to be amended. I'll actually adjust the output of this thing, and I'll make sure that it's giving me something that is more predictable, ideal, and more idiomatic Go code for the sort of things that we're writing in the new code base.
So did you like use the AST to generate Go code, or was it?
Yeah. We would use the existing TypeScript APIs.
I see.
Well, we would use a really cool tool called TS Morph, which uses our ASTs and everything like that under the hood. But it's a really nice API, and we would generate Go code out of that, and that really sped up the development process. And we were able to like reuse all of our unit tests and our input-output tests, like our integration tests. And so over the last year and a half, we've been basically minimizing the differences in all of the tests, right? So we've basically been able to get, like, I would say over 95% of the tests ported over. Some of them don't apply anymore, but like that's because there are certain features that we removed as well. But it's kind of incredible how consistent and fast we've been able to move in that process. I don't think we would have been able to make some of the same strides 5 years ago, for example. But it's been incredible because we've got a lot of great users internally and externally who are giving us great feedback, telling us like, hey, you missed a spot, right? But like that was months ago, right? So it's only gotten more solid in the last few months.
So in general, if someone switches over to the Go under layer, they're not even gonna know, other than that, wow, this feels really snappy.
Right, yeah, so that's the funny thing. It's very interesting to sort of demo these sorts of things. Like, hey, I have a compiler, I have a faster compiler. Isn't that cool, right? And I can show you why there's a little bit more subtlety to that, but yeah, for the most part, most people will not really notice a difference. There is some stuff that we are trying to work on right now, which applies to the APIs. So if you're relying on stuff like the Vue.js editing experience or Angular or Svelte, like there are certain gaps. You'll still be able to get some benefits from this new compiler architecture. And in fact, you'll get like a fully, the story, like the gaps will close over time. Like actually pretty soon, right? We're working with all those DevTool authors. But most projects, I would say, are just like ready to actually start adopting this.
All right, now that we've done the preamble, people have confidence, let's take a look at what you got. Can you come, oh, there you go. You knew exactly what I was gonna ask. Let's take a look. What are we looking at here?
So, okay, I'm actually editing the VS Code code base right now. Like this is actually, if you go to like the VS Code repo on GitHub, this is their source code, right? So I'm gonna actually show you what it is to compile their existing code base today. There's a pretty gross command that I've pasted in here because if you try to compile the VS Code code base with the existing JavaScript compiler or TypeScript compiler, it runs out of memory. So you have to actually modify, you have to pass like certain flags to Node.js just to say like, by the way, I need some more RAM, or you can use more RAM, it's okay. So what I'll also show you right now is not that, because we're on Unix. Okay, so this is htop. This is sort of like a process monitor.
Right.
What am I doing here? Let's just do this. Right?
Look at us going old school.
Okay.
I love it.
Yes. So what you'll notice is that I'm currently on like, if you look at core 15, it's kind of hard to see on this screen, but like if I zoom out, core 15 up here is the only one.
Pegged.
Yeah, it's pegged, right? Like basically, this is sort of like the meme of a bunch of people like construction site and everyone's just like watching one guy dig a hole. And they're like,
everyone's
cool.
supervising.
Yeah, looks good to me, right?
And this is an artifact of basically Node because it's on a spin lock until it has an IO request.
Right, like right now it's just checking actually.
Oh my gosh.
So it's just checking and it's only able to use one core at any given time because it's not able to like dispatch between different files.
No threads.
Right. When you parse, we go one file by one file, And if you say, I'm going to import this guy over here, this file over
There
here,
you go.
then it's like, well, I have to wait for you to finish parsing before I can do anything else, right? So, right, and then it handed it off to Core 28 or something like that. Okay.
So not efficient.
Not efficient. Took 97 seconds, in our opinion. 1 minute and 38 seconds real time, according to the system. That's a little bit hard to see, so I'll zoom in.
Okay.
Okay. So do we have TS-Go? Okay, we don't have TS-Go. So TS-Go is the binary that we have in place of TSC, the TypeScript compiler, until we're out of like preview stage, right? So if we do npm install add TypeScript /native preview.
Look at him artisanally typing stuff in. What are you, some kind of animal? What's going on here?
Let's do this globally, actually, because... all right, cool. So now we have TS-Go. Great. So what you'll see is 7.0, right? The next TypeScript compiler is actually going to be version 7.0, right? That's what we're... And it's nicknamed TS-Go for a lot of people. So if we try to do the same command with TS-Go, right? We'll do TS-Go... we'll point it to the source directory, extended diagnostics, and then we'll also time it too, right? And then we'll do this. We'll look back at htop. What you'll see is that everything is in use right now, right? All of a sudden, all the cores got saturated at the very beginning.
Whoa.
And then
they're awake.
For a very brief second, you might have seen like we went down to like 4, and then we really saturated again. So what happened there was we parsed all of the files in the VS Code code base. I think it's like 1.5 million lines of code. We checked only across 4 cores because checking is not a perfectly parallel problem. And then when we did emit, that was like, all right, throw at all the cores that you got, right? And that made it really fast. So you didn't see it in the background, but that was like 9 seconds or just 10 seconds. We went from like 1.5 minutes to 10 seconds. Non-incremental build, full build. And what I also want to show you as well is that is just the command line experience. So for a lot of people, that's like, well, that's cool. You only have a command line compiler. What else do you got? Well, we have a native preview extension. If you literally go to the marketplace and you type in native preview, TypeScript's native preview is the first thing that comes up, right? And so it says, hey, this workspace, in VS Code, they're already type checking with the new thing, right?
So as you're doing that, why don't you tell us who's using this already?
VS Code, Sentry, Slack, Notion, Figma. Like we've actually been working with a lot of big companies internally and, teams internally and in companies externally, because they know that the quality bar has already been like, it's there for them, right? And they're using it in production, and they've got like much faster turnaround times for their CI. We worked with one team at Microsoft that told us that we were saving them 400 CI hours a month. And so like, maybe in cost, that's like, hey, that's pretty good. But in terms of developer costs, that's great. In terms of like, I'm waiting for an agent to do a thing for me, that's really sweet also.
All right, so we got about a minute left. What do you want to show us in the last minute you got?
I want to show you that basically, let's disable the native preview. If I open up a TS file, you will sometimes see this little spinner here, right? That initializing TS config, all that, right? This is the existing TypeScript experience, and basically what's happening is, it's doing that thing where it's going file by file and not able to load it all. I want you to say goodbye to that.
Let's say goodbye.
Let's say goodbye. So this thing, it's automatically enabled when you install. As soon as I open this, I can restart the language server over and over again. And it's just speedy, right? Uh-oh, you didn't see that.
No.
Anyways, it's fast.
Yeah. Hey, we're still working on code. It's okay.
Look, I mean, there are some rough edges. Of course, during a demo, it had to happen that way. But basically, as soon as you open this thing up, I mean, it's still running at this point.
All right.
Yeah.
This is amazing. Like, all I know is that, like, this is really cool. I'm excited to use it. Thank you so much for spending some time with us, bud.
Thanks so much. Yeah. And all right. Go try it.
We'll
it's available for y'all now.